Is calling you. The universe is calling me. It speaks both day and night.
Oh.
It's full of dark and light. And I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. Fields and forms, path and voids. It all seems with one voice. It's home. Boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Well, hello everybody, and welcome to SkyTour live stream. I'm looking forward to a wonderful evening with all of you. Again, as I mentioned in the chat, show your love to Izabela, who put together that intro video with all of our wonderful shots we've taken. She is really quite talented, and she sees things through an artist's eye. Now, I'm an artist, but you know what? It's not the same. What you see and what someone else sees are two different things. And in this case, I think she sees correctly where we're going. And I think she did a great job. And judging from what people are saying in the chat, I think they agree with me, Izabela. So if you've seen our Instagram, Twitter, TikToks, you'll see other bits of her work. She put together these short little video segments where I go off and on a tear about something really interesting, like this here. This is Measure 11. It's a open cluster, not a globular cluster. I know it kind of looks like Measure 22, which is what we saw the other night in Sagittarius, but this one's not that. And so I'm going to start tonight with the star cloud associated with this cluster that you see right there. It's nice to see you all here. First, I want to run down the list, say hello to everybody. We populated quite a lot already. Renee Cruz was the first one here. Congratulations, Renee. Papa Tom was next. Izabela, hiding in the background, you know, and she's here with us. And we have James Dugan. How are you? How was the life down in Australia? And I don't know if he's a good representative, James. I think he is for the west coast of Australia. But I watch Aussie Man reviews and stuff like that for Arizona. And he's a very funny guy. So that's cool. Asher, how are you? Asher Rial, what is happening? Nice to see you here. So let's see. Robin Curtis is with us tonight. Hello, Robin. And Alicia Vieras is with us. And I just got to see pictures of her daughter Darlene, who went on a fossil expedition. She's 10. And I got to say, that's really something to go hunting for fossils, for instance, or even get a fossil class when you're that young. My first fossil is right behind me that I found up in the a little inlet in Maine. And it was really, really pretty. And it's still here. I've had it ever since I was 10 years old. When I picked it up off the rocks and said, "Whoa, what's this? It's a fossil." I was so excited I ran the half mile back to the house from this cove and showed my parents. And they were like, okay, be home in time for dinner. What? You know, they weren't even excited by it. Like, ah. So, you see, it takes a certain kind of person to get excited about things like that. I like it. It's history. It's the history of the planet Earth, you know, right there before your eyes, preserved forever. That's really important, you know. Hello to Bonnie. Anahata77 is here with us tonight. It's good to see you. I think that we're going to do an exposure here of this guy, Measure 11, just to catch the star cloud sitting right next to it on the right side. So we'll do a 25-second shot here. And you'll notice I'm putting in 25,000. That's because this is in milliseconds. So that goes, as you see right there, it went to 25 seconds right there. All right. So we'll stack this. All right. Start to stack. I was playing with the Lagoon Nebula earlier. It's kind of low right now, but that's all right. So let's see. Now the progress bar down there, this yellow bar, shows us our progress, and we are 3 seconds from seeing the first image for tonight. And here we go. Doesn't look like much, but we can process it. And when we process it and color correct it, all right, now we see some stuff that's interesting. Now the thing is, I think we have a little wind, so I'm going to clear that and let the next one come in and see how that looks. Much better. See right here, only one exposure, you can see these dark lanes in the galaxy right here. Dark dust, the seed of life in our galaxy, in the universe, it comes from these dark, dusty regions. Most stars started life in a dark region like this. That was compressed hydrogen gas with dust And you might say, well, what's the dust made of? The dust is made of a material like carbon, the fourth most abundant element in the entire universe. And it ends up being combined with other elements that are made by other stars. So we didn't start to see planets right off the bat until after a billion and a half years or more, when there was enough supernovae debris to actually allow dust to accumulate in the universe in places where the first planets could form around stars. Okay, when we see globular clusters, those stars are actually the oldest stars that we've seen, because if you look at their composition, those stars actually have mostly hydrogen and some helium in them, and maybe a couple other trace elements, but not much else. So anything other than hydrogen and helium to an astronomer like me is called a metal. Now, we know that carbon isn't a metal. We know that oxygen isn't a metal. But that's the term we use. So metal rich to a star is a star that has something other than hydrogen and helium only in it. Right? So that's pretty cool. Now, the globular clusters only have hydrogen and helium in them. All right? They don't have a whole lot more. So I think that's par for the course for the early universe. But then, as the universe started to make more material and it started scattering it, like here, as you see, through supernovae, then more material was available from which to make planets. Now, hydrogen is the most plentiful element in the entire universe, so finding hydrogen somewhere is not a big deal. It's everywhere we look. In fact, we found planets that have hydrogen atmospheres, and this is James Webb. The James Webb telescope found another planet out there that actually has a hydrogen atmosphere with the water below, possibly a full planetary water ocean. Now, planets like that, where you have a hydrogen atmosphere, are known as Hycean, Hycean. And Hycean planets are something that we thought could exist out there because of the prevalence of hydrogen in the universe. But it doesn't necessarily follow, okay, that we would end up getting hydrogen throughout the universe in a variety of places, but we do. And that's something I think that's really important. So that said, when we look at a Hycean world, which is all hydrogen, and the fact that there's water below, you might say, oh, well, if they don't breathe oxygen, they can't survive. No, that's not exactly true. Because there's also, in this particular planet, they found carbon dioxide and methane, and also another compound known as dimethyl sulfide. Dimethyl sulfide, you say, what's that? Okay, well, dimethyl, two methyl groups, sulfide, okay, a sulfur compound with oxygen. Dimethyl sulfide is a component of organic processes. Now, whenever you go to a beach and it's low tide, you know that stink, right? We call it the smell of the sea. That's dimethyl sulfide. And what it is the waste product from plankton and very, very small animals. So I think that it's important that we end up considering that the James Webb Space Telescope may have just found life on another world. Now, certainly not life like us, but life nonetheless. So dimethyl sulfide might actually be the linchpin for this particular planet. Once they confirm the results, we'll know. Yeah. Asher says, well, this is amazing. Yeah, it really is amazing. And so, and Sean says DMSO. Okay, the thing about dimethyl sulfide, as I said, is that as far as we have known, it's only made by living things. So that's pretty cool, and that's the latest James Webb finding. Now, how are we doing here? We are up to 13 exposures of Messier 11 right here. This is, again, this is known as the wild duck cluster. Why? I can't tell you, but it's known as the wild duck, and it's Messier 11. And I'll put up the information so you have it. And again, it's an open cluster. All right, and meaning it's being an open cluster, it's a cluster that's actually not I screwed up. That's not M22. It's M11. My mistake. I typed M11. I thought, but I fat fingered it. I apologize. Okay. It's actually a open cluster. So open clusters don't generally show any characteristics of anything other than stars that are close together. Some of them are associated with what they call nebulosity, nebular type appearance, and that's something that we can expect to see as well. Not here, but in general. So bink, there we are. M11, the wild duck cluster, and get rid of that. There we go. So the wild duck cluster is this one that we're looking at right here, and it's really pretty. It's really pretty. So we'll let that develop a little bit longer, and then we're going to name it up here, and we'll save it, okay? That way, if you want to check it out at some point, you can. And that'll be something exciting to do. All right. So let me do a wild duck cluster. And it's an OC, an open cluster. All right. And Izabela, thank you for asking people to put questions in caps. I appreciate that. And I can actually answer both in chat and live as well if I don't catch your question directly. Okay, so if we go over to Stellarium here, which is our linked system for checking out the sky, I can show you where we are. We're leaning way over. If you look here, okay, here's the ground. So we're looking way toward the southwest. All right. And so the stars of summer are fleeting. They're going to be leaving us. We're almost to Aquila the Eagle. And Aquila the Eagle looks like this. You can see the eagle here with its wings outstretched. And we're down in Scutum, the shield, right here. Okay, and that's kind of where we are. We're by the Scutum star cloud. And the star cloud is over here to the right. And with this particular telescope, we've changed the camera, as I've told you. Gives us far better resolution. And hopefully I'll be able to show you and send you in our community tab in SkyTour Livestreams channel. I'll send you the result of a private stream I did last night where I went to the North American Nebula and I literally went dink, 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 dink. I did 8 separate 15 frame exposures and got the entire thing. And Izabela actually did a composition of it, which is really nice. And let's see if I can find that and show you, because I think that's pretty. Oh, I don't know where it went. Oh, yes, I do. There we go. All right. So you'll see, if I can bring this up, you'll actually see just what it looks like now. So we'll let this cook away here for a few more seconds, and then I will go dig this up for you to see if I can show you. I don't see why I can't. All right, let's see here. No wonder. All right. Okay, here we go. Again, we're going to let this cook for a bit. It's like cooking, isn't it? All right, let's see here. Okay, this should do it. All right, let's try this. Nope, hold on. I might be able to do this. No, I'll keep this going for a moment so we can do this. All right. One second. Gosh, it looks really pretty too. Let me see if I can capture this. Maybe window capture will do it. Let me try that. Yeah, that'll work. Okay. So this is the whole North America nebula. Look at that. Now, our camera usually does just a little bit like this size. So I spent last night just going and doing the whole thing. This is Izabela's composition that she put together. And I will be doing more of such compositions. But when you do these, you find things you didn't see before, you know. And like I found these beautiful dark nebulae down here. Okay, and then coming up here, I found this beautiful thing up here, really pretty. And I got a better insight into the Pelican Nebula here, you know, because you can see this dark nebula which is over it and mixed into it. So it's really an incredible region. And again, you can also zoom into it and see it really like this. Now this, what we're seeing here though, is actually just the PNG file that's been operated on. It hasn't even been, it's not even the actual photographically processed shot, so it's really something. But there we go. So there you saw it, and that was from last night. Okay, so here is this. We're gonna save this like this is now. All right, so that's been saved. So that's saved now in our FITS file format. That is the astronomical file format. And for those that want the FITS file to work on and to process themselves, that's what you do. That's where you go. You get that. And you, where you want to find it, how do you get to it? You go here. You go to skytourlive.org right there. Okay. And you follow the instructions on the second panel down in the dark gray. And we'll tell you how to get to this particular server on our skytourlive.org site. So you can check it out. Okay. So this has been saved. So let's go back. All right. All right, let's get out of this now, and I want to go back to our close out Wild Duck, and I love doing getting the gestures to work. All right, here we go. We are there, and now I'll just bring up the green. So this is our night vision mode to help us check things out. Asher Real says, I like my globular clusters sunny side up. They're all sunny side. This isn't a globular cluster though, Asher. Leon's with us, old school. How you doing? I'm glad you could make it tonight. I know you told me earlier you were going to hope to make it. It's nice to see you here. Hello, Vince Giglio. How are you? Maybe they were playing duck hunt when they... Well, back then, duck hunting was probably a big thing, you know? Okay, so let's come back to our stellarium that's linked to our system here. And let's take another view. Head up north here. We're going to spend some time going up north. But right first, what I want to do, as we move up towards Cygnus, is I want to take us to the Dumbbell Nebula and check it out. There's a lot to see in the Dumbbell Nebula. So let's go there now, find out how that looks tonight. It seems, you see the telescope's moving right here, okay, over my head, right? And the dumbbell is going to be pretty much right overhead, almost overhead. So it's not a bad thing at all. You know? Hello, Francis Palmer. Nice to see you. Thank you for joining us tonight. I'm going to move our telescope westward to pull the dumbbell toward center. Okay. Now, the dumbbell is really bright, and it's a planetary nebula. These occur when the star that's been taking hydrogen and fusing it into helium under extreme pressures and temperatures, when it runs out of hydrogen, the core of the star starts to contract, and that has the effect of pushing outward with lots of heat and radiative energy, and that radiative energy pushes the star out in the envelope. The only thing doing the fusion is here in the core. The rest of the star is as big as the house, okay? And that material is pushed away from the center of the core, and that's why we see, a massive red giant form, all right? And when red giants form, they form twice in the star's life. The second time they form, they do these thermal pulses. They puff up and go down, and they puff up and go down. And each time they do that, they puff off some outer layers, and we see that here. Okay, these outer layers. And what's that leave behind in the center? Well, as it pushes off all those outer layers, we actually have the exposed core that we can actually see. And then that core collapses and shrinks down and becomes a white dwarf. Right? And white dwarfs are about the size of the planet Earth, and they're extremely hot, 45,000 Kelvin, and they give off a lot of their radiation that they give off in the ultraviolet. So what that tends to do is that ionizes the gas around the old hulk of the dead star. And this is the fate of the sun you're seeing right here. This will be our sun someday. Now, the dumbbell is so bright that we're only going to do a 15-second exposure. We don't need to go any brighter. So let's go and stack this. And we will see our previous buffer with Measure 11 in it. And then you can take one last look. You see the dark nebulae up in here. All right. And we'll clear that. All right. And now we'll see the dumbbell. Look at that. Now, let me zoom in on it for you, because it doesn't take much to get good detail out of this. And let's color correct number 1. So we get our curves all lined up. And then let's do our processing. Now, in order to see what's going on, and because this camera allows us to have so many stops photographically, that means that we have a lot of options to actually dig down through the outer layers and the brightness to see the interior of the star like this. All right? So you can actually see what's going on this way, and that's what we're doing right now. Okay? So let me zoom in on this some more, because you can see right there in the center, that little blue thing right in the middle is blue because it's hot. And it's blue and tiny because it's a white dwarf. Now, this nebula is well over 1,500 light years away, and we can still see something the size of the Earth in there glowing brightly. And if you can just think of the mere speck of size that this star is at this distance, the fact that you can see it at all shows you how incredibly hot and powerful it is. And the white dwarf is a true trooper in the universe. There's many of them, and they're responsible for a great many phenomena that we see. Hello, Marco. How you doing? Francis says it's 3:45 a.m. in the UK there, and stormy. Oh, and good night, Darlene. Sorry, I saw your mom. Well, she's probably can't even hear me anymore. But I saw that. Thank you, Alicia, for letting me know. Okay. So, old school Leon says 3 to 4 billion years. Our sun will last another 4.5 to 5, actually. So don't pack your bags yet. Okay. Yeah. Okay, now Francis is asking a question. Would a planet with an atmosphere inside this nebula be affected by it? Yes. Okay, very good question. He's saying, what if there was what if this nebula, which goes out a couple light years, by the way, from the star, what if this nebula went into another star system where there were planets and they had atmospheres? Would the gas affect the planet? Well, it depends on the density of the gas. Okay? If the gas is not very dense, then no, it probably wouldn't affect the planet. There might be some atmospheric heating if it was bathed with gamma radiation, which this star here is going to pump out lots of radiation. And again, most of it's in the ultraviolet, so we're going to see a lot of ultraviolet radiation coming out from this star, and it makes it out a couple light years. So it's ionizing the gas. So this gas in particular is too thin to ruin a planet's atmosphere, I think. But the UV radiation that would be striking the planet could do a lot of serious damage. Okay, so it's a trade-off. Okay, you get some atmospheric heating from this extraneous gas, and you will also get UV radiation from this very hot dead star. So really, that's a really good question, Francis. Thank you for asking that. Yeah. So let me change the name here. As you can see, you don't need a lot of exposure to really get the Dumbbell Nebula good, or well, you know. And Dumbbell is spelled with 2 B's and 2 L's, just so you know. So now let's see if we can pull out and tease some detail out of this. If we drop this down, we can start to see some convolutions in this material here. Now it's an hourglass shape. It might be a precessing star, okay, that's shooting stuff out along its north and south poles, or an equatorial spinning star that's shooting stuff out on the equator. But it's likely it's a north-south effect. Now, this nebula here, these types of nebulae where you would expect a planetary nebula around a star to just go off in spheres, okay? Sphericals in all directions, spherical gas release. That's typically what you would expect. But no, in this particular case, we're seeing that we have more this way and that way on a nebula. You know, more at the 11 o'clock and 5 o'clock positions. Now, why is that? Well, there's a whole science about the shape of these planetary nebulae, and the shape of these nebulae are called bipolar. And bipolar means that there is a preponderance of material at one end and the other opposite to each other. So from on the poles, basically. So this is something that we're looking at here. Hello, Ronald. How are you? Hi, Cindy Murphy. Yeah, so that's pretty cool. So Dumbbell is really a very, very interesting object, and fascinating to see it because it's so incredibly detailed. There's so much here, So we'll let that develop a little bit. We've got 24 shots. We're going to go up a couple more. There it is, Dumbbell Nebula, right? And there we are. Okay. So, there we are, the Dumbbell Nebula. And let's push that over. Here we are. ERRT Radio is Ronald. You know Ronald from the other night. He was our special guest on the stream here today because he's one of our largest supporters, and he is a top tier Patreon supporter. And for the top tier, he gets to come on board with us for a night and check out all his objects. Ronald, I have to tell you, I processed the Andromeda Galaxy that you requested, and it looks beautiful. And I processed the double cluster for you, so we're going to get those two as well, because you get those highly processed images for free for your contributions. Wow, this is cool. So we're going to go to 30 on this. Let's zoom in some more, shall we? Yeah, here we go. Let's just do that. Look at this. Wow. Now, if we process this to where it wants to go, look what we see. Okay, look out here. See how much more stuff is out here? I think it's actually easier to see if we back out. Now you can see much more stuff is out here. So that shows that this material came off either at some point in the past or later on and overtook the stuff inside and continued to go out. Maybe there could have been an explosive outburst and it could have overtaken slower moving material. So it's hard to tell with planetary nebulae. That's part of the problem and part of the reason why they're so hard to tell the distance of. Because we know that when something like this is made, we know that the nebula itself is the result of the star pushing off its outer layers. And we know that the green color is doubly ionized oxygen. Remember, oxygen is the third most abundant element in the entire universe, so it stands to reason we'll see it some places. The red is hydrogen, the most abundant element in the universe. Some of it can be neon and some other materials, sulfur and so forth. But the bottom line is, okay, these really faint wisps out here, and if we actually pump this up artificially to a ridiculous proportion, you can see the extent of it. Okay, we go really far out. All right. So this material here is faint oxygen wisps, way, way out there, ionized oxygen. Now, these nebulae can only go out a certain distance, and beyond that, okay, the hot central stellar remnant, the white dwarf in this case, no longer can ionize the gas farther out. So the question is, if we just come back to the pretty picture, okay, is this the limit of size here? Or is there more oxygen past this that went out previously that is no longer ionized and thus invisible? See? So there's a lot of questions, a lot of reasons why we don't know or can't get easily the distance to these planetary nebulae. They're notoriously hard to find. Again, you don't know if material's overtaken it and gone faster outward. We're just seeing the end result. We're not seeing the processes by which they got to this point. So it makes it tricky, but I'm telling you, it's actually still a great deal of fun. Okay, let's actually try to get a little more detail out of it. Okay, so we just added a detail grabbing filter, and if we do this, let's see if we can grab this here. All right, now we'll grab this and see what we get. Look at all the modeling in here. It shows you that the material that came off this stellar remnant, okay, is actually not just uniform. It comes off in a variety of ways. It could have been uniform coming off the star originally. The bipolarity, this thicker this way and this way, is due to those polar jets potentially of material pushing up to the north and down to the south. However, it's not crisp and clean. It's not just a smooth, as what we call homogeneous material. It's actually broken apart. It's got compressed regions and distended regions. Like here's a compressed region and here's a less compressed region. Why is it like that? That could be because the interstellar medium that it's pushing into can be more dense and less dense. And so it could be that it's limiting the amount of material that can go past a certain amount, a certain region, or the material has thinned out because it was moving faster at this point. Again, all part of the reason why it's really, really hard to actually determine the distance to such a creature out there. So that is our Dumbbell Nebula. We will save that. You'll see up there that our green bar indicates that it's been saved as an astronomical file format, and then we'll save it exactly like you see it here. Okay. So that's saved up on the server. And to see the server, you can look in the chat and see if anyone puts the link to the location, or you can go to skytourlive.org and go check out the server yourself, because all the imagery that we have up there, all this is called a raw processed file. All this imagery for you is free. You can take that down. If you join our Patreon, then we get you 4 highly processed images a month, and then depending on the level of the tier, you can get more than that. So it's really a cool thing to do. And there's Izabela giving a shortcut to tonight's folder. So what's happened is, as soon as I save it, it leaves the observatory right here, which is out in the middle of the Arizona desert, which is about 2,500 miles from me right now. And it races to the cloud where it gets deposited in our server. So we're using Starlink out there, so every now and then we will lose service for a couple seconds. But our service is getting better as we speak. It's getting better out there. All right. Okay, so we'll save it one more time. And there you go, the green bar. It's a FITS file. Now, that looks remarkably poor when you look at it, so you have to process it to get the data out. But when we save exactly as you see it, that doesn't. That is this image you see right here. Now, if you actually want images of that brighter green stuff out there, then what I could do, let's see if it'll let me save it twice. Here we go. Okay, so it's been saved twice. And now it's got another save out there with the extra material out there. As winter approaches, we're going to see the most incredible views. There's another star that that sports a beautiful green nebula like this. And that star has created a nebula called Thor's Helmet, made entirely differently from this, as far as we can tell. This one, made by a dying star's white dwarf, and that one that we'll see in the winter, Thor's Helmet, made by a star that explosively puffs off its outer layers long before its demise. And it looks for I look forward in that region to seeing a supernova someday, because all these types of stars there that we're talking about, not one like this. This one's already at its lifetime. All ththose other stars are called Wolf-Rayet stars, and those guys will go into a supernova at some point. I want to say hello to John Proctor. How are you, John? It's really good to see you here tonight. John, of course, is another one of our SkyTour patrons, right? And I do want to, I do want to pay homage to our SkyTour patrons. We have John P. Okay, that's you, John, at the top. Izabela M, Ollie B, Chief McCyber, Vera C, Ronald T. Ronald T is ERRT Radio. Martin W, Raymond B, Cindy M, Cindy's here. Susan W, Diane H, and JSCO 77. And we don't have but Ronald and Vera and John P and Izabela with us tonight. The others aren't in here right now, as far as I could see. But there we go, and those are our patrons, wonderful people. Supporting us is absolutely so important, And Cindy Murphy asks, is the weather better because it's colder and the sky is better? Colder weather is more dense. Colder air is more dense. So cold air can be unsteady, but so can summer air that's moving around, right? But cold air can be more steady if it's still. Fast-moving cold air isn't. But slow-moving cold air is really good for us, and we can actually get some really beautiful photos if the air is really cold. However, this is the Arizona desert, so the coldest the air is going to get outside the observatory is going to be about 40, maybe 35. So right now our camera is running at 14 below 0 Celsius. We actually have the sensor being thermoelectrically cooled so that we can see these images without all kinds of noise, All right, so there's our Dumbbell Nebula. So let's jump out of that. There's another location I'd like to check out while we're in the region. Okay, now, so Dumbbell and boop goes away. All right, so let's take us back down to our full frame image. Okay, bring up our planetarium. Now let's go look at something else up here. All right, this is something I wanted to image again that I haven't yet, and that is this guy right here, that little nebula. Okay, now if you want to know the name of the nebula, we just have to go into our DSO, or Deep Sky Object Catalog, and turn on a couple catalogs, and you will see this object show up. All right, and now in this region, we go here, we zoom in, and you'll see that now we have an object. All right, it's called the Cygnus Star Cloud, or the Tulip Nebula, and we'll check it out. So I told the telescope to go there, and if you look, you can see the telescope is moving, and of course there's a dead giveaway. Star is zipping by at high speed. And by the way, Cosmic Ray, how you doing? He keeps asking about blobby stars. Those don't look blobby to me. Okay. So let's let me just pump this up a bit to figure out exactly where this okay, it's here. All right. So we're going to move a little to the west. So bring the Tulip Nebula into the center. All right, and a little south to pump it up one notch. There we go. Okay. Ronald. Clean your glasses, Ray. No, these stars look pretty good to me. Alright, so we'll go back to 200. Now, with this particular camera, the best speed, and make sure, by the way, you guys are on 1080p. Alright, make sure you're in high-res 1080p on your YouTube channel that you're watching this on. Our channel, make sure you got it at 1080p, or the stars will appear blobby. That was actually a good point Ronald just made. He says, or your screen resolution needs to be popped up there, Ray. Is the Witch's Nebula visible tonight? The Witch's Broom is, and we can show you that too. All right, so this is the Tulip Nebula, and we're gonna view it now. We're gonna check it out. This will be a 25-second exposure. You notice where the telescope's pointing, it's pointing almost straight up. So we have a good view. Little pointing to the west. So you see our yellow progress bar over there. Okay, that's good. And now we'll go into our live stack, and the last image we saw for the live stack is our buffer. Right here is the Dumbbell Nebula. We'll see that in just a sec. There it is. We're going to clear it, and we're going to get out of that. And we have our Tulip Nebula, the first one. There we go. Look at this beautiful nebula around here, too. It's not just this. It's this. It's all sitting amid all that. Now we shall... our curves are actually pretty corrected, so we're good there. And we will process this a little bit. It makes a little bit more contrast for you. Isn't that gorgeous? So as we develop more, remember, we're stacking. And what are we doing when we say stacking? Well, we take an image, then we take a second image, align it with the first, star for star, so it's lined up exactly, and then we put it on top. And we do it again and again and again. And so this provides us with a nice image sandwich that allows us to see every detail. Everything that's a real detail inside the images we take like this will rise to the top as a very tall spike in the data. And stuff that's noisy, okay, like if we zoom way in right now in this, it's still noisy. Watch this. When we zoom in, okay, see all that noise in there? That's all noise, all right? And with each exposure, that noise gets reduced and reduced and reduced, and that reduction is very important to see. So let's see if, when we're almost done here with this next exposure, let's see what this looks like, and if we see a change. Yeah, there was a small change, and this noise got reduced slightly. So the more you stack, the more the noise gets reduced. And the end result is that makes an object like this, all right, able to be seen like this, where you start to see a beautiful object appearing out of the darkness. It's really pretty. You can always overwhelm it. You can always overwhelm your images like this, okay, and always make the noise pop out. But you can process too and just remove just the right amount of noise so that it's just beautiful to look at. And that's kind of what I'm doing here as we're stacking. I'm removing some of the noise, all right, so we can see the detail in there without seeing the noise. And Leon says, hey, the stars are less blobby at 1080p. That's correct, they are. And Ray, I think it's a conversion issue at your end because the stars are not really blobby. If you go back and watch the streams over again, I think you'll see that, and hopefully you will. Yeah. Okay. So we'll let this percolate a little bit. We've done 8 exposures here. Leon says he checked and he was sitting at 360p default. Yeah, that's crappy. Get the most out of this, right? Right. By the way, let's welcome Leon, old school. We've talked in Facebook here and there, and it's nice to see him joining us. He was here the other night too, actually. But it's just welcome him the way a SkyTour family does, with open arms and a deep sky. Okay, let's try this. Let's pull that down, and let's get rid of this, so we could just look at this develop here. Look at that go. Thanks, Leon. I'm glad you really like it. Hey, Fantasy, what's up? And Mr. Django from Belgium. How are you from across the pond there? See that, Leon? Everybody here is friendly and kind. You know, we're the right people, man. We're the right people. We have a lot of good people who listen to this stream, watch the stream, contribute to it, help us. You know? Mr. Django says, rainy days and cold. Yeah. When I was in Norway doing a speaking tour, my first couple days there, I was traipsing around the Bergen forests and sinking in mud up to my calves. And that was weird because I was actually with police officers and detectives hunting for a body of a deceased person. And why was I doing that? Because the person I was speaking with was someone that had direct knowledge of where the body was buried, because she said that the person came to her psychically, and they were digging around out there and they felt something under the ground, and so I don't remember exactly how that turned out. I don't know if they found the missing person or not. But either way, I ended up, losing my one of my shoes in the muck out there, and it's still in Bergen, Norway, somewhere in the forest. So they had to stop laughing all the way to let me get a new pair of sneakers. You know. Yes, the fun is to be had. So there's the tulip. Look at that. No, Izabela, not while I was there. She asked if they found the body. No, not as far as I remember. But which was as good because, I certainly didn't want to see it. Felt bad, tremendously bad about it, but hold on, let's just do this. Ready? Boop. There we are. Okay, Tulip Nebula. Let's move it up a little. So here, when you look at this, what you're seeing, okay, very clearly is a region where ionization of hydrogen is taking place, right? And this is dark dust, not a void in the stars, not a void, not a lack. Okay, not a lack at all, and not a lack of stars, but dark dust over the stars behind. So the dark dust is here, and the stars are behind, the nebula is behind. You know. Mr. Jango says, ha ha ha, still frozen in the mud. Yeah, it's still, my sneaker is still in the mud. And we had climbed 300 feet up a hill. And I had to go back down that hill with only one sneaker on. But the photos are just unreal of this forest. Everything, I mean, everything is covered in green moss. You expect to see Swamp Thing come out. It's really, really cool. I would not have traded that experience for anything. And I want to give a shout out to Kat Thorvaldsen. She was the one I was speaking with over there, and we were doing a speaking tour. And she's a very, very talented lady, and she's in astrophysics. So it was really, really exciting. So this is developing nicely, so if we start to zoom in, okay, we should be able to see some nice detail in here now. Look at this dark nebula here. This star may be a foreground star, and the nebula may be further back. Not sure, but they also might be K giants or supergiants of some kind. Just because they're bright doesn't mean they're supergiants. But, you know. Ronald says he could tell stories. I'm sure you can. This is nice. Okay. Let's bring back our telescope here. All right. And then let's bring back and dock our... Here we go. We're going to dock this up here. All right. And this will be the Tulip Nebula. Okay. And we're going to save it after 25 shots here. All right. And we'll save exactly as seen. There we go. Okay. Now we're going to deviate slightly from the Cygnus Milky Way, and we're going to head to another location that's Cosmic Ray's favorite. Let's see, Mr. Django says, see you all next time because I'm off for 1,097 kilometers to south of France. Wow, hey, all right. Well, it's nice to see you here, and thank you so much for joining us for a little while anyway. Look forward to hearing all about your trip to the south of France. See, that's the thing about being in Europe. You can just go to the south of France like nothing. Okay, bank. Yeah. You know, here it's a big trip to go across the ocean first. The flight to Norway was long. Oh. Especially because I was in a aisle seat. I wanted a window seat. I just love the windows because I like looking out, you know. It was a 787. It was a beautiful airplane. The windows, there's a button, and the windows dim electronically. You don't have a shade to pull down. When we flew over Greenland, it was unreal. It was otherworldly. And the sun had set, and then it came up again, and then it set again as we went over the pole, near the pole, not over the pole. So that was pretty cool. Really interesting. So I really thought that was a very, very neat trip over there. All right, so now we're going to go to this by request. This is Ronald's requesting the Witch's Broom. So we're going to head there now. And that star is called 52 Cygni. All right, and 52 Cygni is a foreground star. It's not a star that's actually in the nebula. And there it is right there. And the witch's broom goes down here. You can see it because it's just slightly there. Yeah. Cosmic Ray says, the observatory spider should not allow this. That's very funny, Ray. Okay, so we're going to move this over. We're going to go a little to the west, so we'll center it up. New telescope's equipment has been finalized. It's going to be an 11-inch Celestron system, and it's going to have a duo camera on it that will both image and guide. And the camera is twice as expensive, but when you look at what you have to do for what's called off-axis guiding or a telescope to do guiding separately, the cost is about the same, if not even a little more, than to get the camera that can guide at the same time. You know? All right. So because Halloween approacheth, this particular object will really be nice. And so I'm going to probably be we're not going to get the whole thing in here. We're also going to have a filter wheel on the telescope so we can actually put the filter we're using here in. We're going to have a second one. I've got it already. And then we're going to have other filters in there to do what's called narrowband astronomy as well. Hey, it's Bill. How you doing, Bill? You want to come on in? I should be able to do it. Bill Skywatcher. Let me see if we can add him in here. Sure we can. I should be able to do it. I'll have to get the source done here. Alright, hold on, Bill. We're calling. Okay, make sure you turn off your volume. No, I heard myself coming through. Okay. All right, let me add you in here. Let's find you. Steakums. Ow. That's awful. Yeah, no one wants to hear that. This is the night vision mode I'm doing right here. I'm trying to set up your source here. Just a sec. Okay, I believe you are in now. Can you talk? Hold on, hang on. I'm not getting you coming through yet. Well, you can't hear me. Oh yeah, you gotta be able to hear me. Oh, I see why. Okay, you can hear me again now. And let's see, we gotta get you in here now. Let's hear you talk.
All right.
There you are.
Cool.
All right, you're in with us. Very good.
I see the SkyTour family in chat.
Yeah, a lot of them are here. They're here, yeah.
And I heard you mention about the telescope, and that's, I guess, is it publicly known that that's all thanks to Ronald?
It is now.
Oh! Oops! Oops! Oh my God.
I mentioned Ronald's one of our biggest contributors, and Ronald he's helping us with the telescope, so that's very, very kind of him.
Yes. He's been a big supporter since the beginning.
Yeah, yes.
I mean, even coming here, meeting you, he gets so excited. You know how that goes.
Oh, I know. Yeah, he drives 23 hours from Minnesota to come to Pine Bush. Hey, wait,
So-
tell me this. When is Pine Bush this year?
The first Saturday next year. The first Saturday in June, you'll probably be at Contact.
Maybe. Contact, they had to change their dates a little bit because of a hotel thing. So I might have time to do Pine Bush, but I will find out.
Oh, you'll find out for sure from me after you tell me what's going on.
I'm
But
sure.
We're both going to be in Roswell.
Yes, we are. That's right. I'm doing a 25-second exposure here. Look, there goes a Starlink satellite. Hi, Starlink. There goes. Yeah, you see this. You can see this little spire here. It's very faint, but we're going to be showing that very, very nicely here in just a moment. So,
Did you just start streaming shortly ago, or how long have you been going?
I don't know. This is the Tulip Nebula we just shot. So that's out up on the server, so we're going to clear that.
Did you share what you told me earlier today? That image?
Oh, yeah.
That was...
Yes.
Okay.
Yeah, I showed the one that actually the Izabela put together.
Yes.
It was very nice. Yep.
Awesome. Yeah, so thanks to Ronald for his contribution and support of SkyTour, for sure.
Yeah. Okay, look at that. That's
And
a...
everyone else as well.
Yeah. This is a supernova remnant in Cygnus that we're looking at right here. This is the Western Veil. And we're going to do just a few exposures of this, and then we're going to drop down to get the bottom part of it. And then you'll get, that'll be the whole witch's broom. Cosmic Ray says 71 minutes ago we started streaming.
How appropriate, which is Broom.
Yeah, that's right. That's why I said it's a Halloween object, you know? Yeah.
Is there any other, like, Halloween-related nebulas that look like something like a bat, or you know what I mean?
Yeah, you got the Skull and Crossbones Nebula. We have the Cosmic Flying Bat Nebula. We have that. So there's a few things that we can do, you know, and see. You know, this camera we're using, by the way, this is the new camera, and it may not appear, but the detail we see in here is way more than we are used to, because our other camera was not nearly this high resolution. We are literally at double the resolution, and there's the bottom of it. Let me just back out. So there's almost the entire piece right there. Okay, and then the central veil is over here. You can start to see it. The camera has almost double the resolution than we had before.
Wow.
And it's really cool, you know. Cosmic Ray says, the observatory spider is working to pull the plug. Don't say that, Ray. Don't say that.
Definitely don't say spiders.
Shake your Ray. Shut up. Yeah.
Gotta bring up spiders.
Oh, yeah. I mean, we had that beautiful tarantula underneath the computer bench out there. Ren and Tara's husband let it crawl up on his hand and just sit there. You know, they're very, very docile and gentle. Nope. You know, I just don't want to be a mouse. You know? Yeah. No, I mean, the fangs are only about that long, but that's still long enough to do damage. It'll hurt like heck.
No thanks.
Yeah, I understand.
Yeah, it is stunning to see these images. Obviously,
yeah, look how beautiful.
Is there anyone that is comparable out there with Earth-based, you know, a person that has a telescope? I'm not talking about an observatory in Hawaii or somewhere like that, but a person using how many inches is this one, Mark?
How many? This is a 10-inch telescope, 10-inch diameter. Yeah.
That gets images like this. I mean, really.
Well, I mean, anyone can get images like this, but I will tell you right now, this telescope here in this image right here that you see, okay, on the left there, in the black and white right there, there's no other telescope on the planet that has this setup, because our telescope is the one and only that's been converted. Our Meade telescope is the one and only one on the entire planet that's been converted to do this wide field work.
James has a question. What F ratio are you going to be running on the new scope? at f10, f7, 6.3, f2?
I think it's going to be an F7 when we're done with it, James, because we're going to be putting in a reducer, a focal reducer, and then we're going to be putting in a duo camera, one that'll, like I mentioned, will both guide and image at the same time. And then we're going to have our filter wheel on there too. That's going to have our narrowband filters for doing very detailed photography, and then we'll have a filter exactly identical to this one called the UHCS, which is going to do that. It's a 5-place filter. And then the last spot currently has a spectral dispersion grading in it, so we can actually see the spectra of the stars a little bit. Yeah.
Fantasy also adds this, and I think you've discussed this in the past, possibly having university or colleges get some time of use with the observatory. Is that something still in the plans, Mark?
Yes, as a matter of fact, I've been writing a usage manual for it. But here's the thing. As much as I want to do that, it means that then they're going to have to have private use of the telescope. And that means that you guys don't get to see anything because someone's paying me money to use the telescope. I don't want to do that. I want to keep doing this so you guys can see it, everything, you know. And if we can bulletproof it enough, I could make it available to some of you to run it, as long as we have everything in place.
Right.
And then I could sit back and watch you run a stream for once. I mean, that's actually
that'd be interesting.
It's one of my goals is to make this available to everybody. You know.
Now, obviously, Mark, you have a Patreon. You know, if
I do,
if enough people support what you do, and I think it's very important. This is educational experience for so many people globally. There's not to say that in the future, I know you got the new telescope going in soon, but that doesn't mean that you could put an additional pier and have one exclusively for that purpose.
Oh, exactly. Exactly. By the way, I'm just sharing my window with you now so you can see it.
Oh, cool. This is why I see it in real time.
Yeah, it's 30 seconds delayed, or maybe 10 or 15 seconds delayed. So now you see it live.
Cool. I see it.
All right, good. And then,
but that's something that can be done. I mean, in the future, that's not another question.
Yeah.
To have one specifically for that use.
Yeah, absolutely. Sure can, and that's something I'm looking forward to doing.
You know, would be an interesting, maybe a little prequel to that, is maybe that you get to tour universities and do the astronomy, like a session, doing these type of streams in real time so they can actually see, and you can conduct like maybe some kind of a seminar.
Yeah, actually, that's part of my my goal, actually, because I talked to my university, and they're not even remotely interested in doing anything with me. Not because they don't like me, but just because I'm an unknown quantity to them, even though I graduated there with my astronomy degree. But that's okay. You know, I think that it's probably more likely that I talked to the wrong person there. Instead of going to the president of the university, I should have gone to the science department first.
Yes.
Yeah, and so that's what I'm going to do.
But at least now, moving forward across the country, I'm sure you can gain interest in what you do.
Yeah, I mean, we got a grant already from a fund for. It's not a whole lot of money, but it was a grant that's enough to help us with our costs of some of the the flights and things I had to do to go out there and fix the telescope a couple times. So that was wonderful.
Did you get the window seat?
Of course.
I know Mark likes the window seat.
I have to look out. I just can't. I can't stand an aisle. I'll give the aisle up. And the middle seat is tolerable, but then you're like this. You're crunched, because you got the guy on this side and the person on this side, and you're like, ugh.
Oh my gosh. Yeah. I know the drill. Oh my gosh.
It's all right.
So, what do I see? This is the witch's broom. Any other parts that we're gonna see of this?
Yeah. This is the. Okay, let me do this. Let me first. Let's pop that down, And let's remove the telescope and full screen this. And then let's actually zoom in. All right, here we go. There we go. Look at that.
Nice.
Okay, so this is the whole. This is actually the whole witch's broom, pretty much. So I thought we might have to do a little bit lower, but we don't. Here's what's interesting: these tendrils, these that you see here, all of these tendrils, and you don't get to see it because the screen is shared. But I'm actually I'm a floating head now on the other screen, pointing things out.
I'm watching.
Oh, if you got the other one, you see what I'm doing. These green tendrils are really interesting because, how were they made? And that's the question. Were they made with the supernova explosion? How did those get made? And one of the current ways of thinking is that all of these tendrils that we see. Look at how beautiful gossamer this one is right here. That's beautiful, and for that to look like that, just like that, means that it probably has the influence of some type of charged particles. In fact, it might be electrically charged. This nebula might be electrically charged. It's material moving outward into the interstellar medium, combined with collisions with dark material that's out here that could carry a charge and cause all kinds of charges to be freed. This is ions, remember? So this is glowing because it's ionized. And if you ionize an atom, you knock the electrons off it, right? And thus you positively charge that nucleus.
What causes it to have that stretched effect like that, Mark?
Well, we don't see it in 3D. It could actually be something that looks like this, but seen from this angle, okay? It could be something like this, where it looks really thin this way, but if we saw it from the other side, it'd be fat. It's an expanding shell of material that came out from a supernova, which is where this came from, right? So this was born in a supernova. This is a supernova remnant. Again, this is a star way up here in the foreground, and the nebula is way back here. Okay.
So what you're saying is, if you were at the left of the screen looking to the right from that different angle, it may be completely wide. It may be larger.
Yeah, I mean, this part right here, for instance, that we see right there, that could be much closer to us than, say, the part right next to it. They look like they're next to each other, but it could be that they're separated by several light years of space, and it's just projected on the. You have to be prepared for that kind of thing with the universe, And what that means, by the way, is that the stuff that's closer to us, we're seeing before. At a time sooner than the material right next to it if it's further away, because that material's light didn't get here until a certain amount of time later. So we're seeing everything as we're seeing everything in space at different times. Go ahead.
That's what I was going to say. So you're saying this could be light years apart, this event that occurred, but it's spread light years apart. So we're seeing some of the stuff that is closer or maybe even further away.
That's right.
But you're saying it's light years apart?
Possibly, sure.
Wow.
I mean, obviously, these two strands right here, even if they were at the same distance from us, okay, they would still be light years separating these right here. Okay, so this occurred around 8,000 years ago or so, and it's about 1,800 or so light years away, I believe. And so these are definitely separated by a distance of like a light year or more.
That's incredible to even think about.
Yeah. And it's originated many light years to the left of the image, because this is the actual progenitor, the original star, was way over there somewhere. Okay, and when it blew up, it blew out like this, and this part of it reached here. And that's the snapshot in time we see right now. Okay.
Wow.
Yeah.
That's amazing.
It is. So here's what I'm going to do. I'm going to save this. This is Witch's Broom. I've got it that way. I'm going to redock this. All right. So there we go. Put that back. And I'll bring my telescope back in from the other side there. There we go. And now we will save this. All right. And then after that, we'll go on to the next segment of this entire complex. Save exactly as seen. Here we are. So the astronomical file and the ping file, the graphic image file, was just saved there. All right, so now, in fact, let's just do one more zoom in here so you can kind of see more detail.
Look at that.
Look at all these filamentary structures in here. So that's why they were thinking maybe electricity is involved here. Maybe there's charged particles that are partly responsible for shaping this nebula. And that's something that is an interesting possibility. All right. So that's cool. So now if we actually go and take our telescope and jump back into night vision mode, we get our green sky back. This is our green night vision view. And now let's go to our planetarium. All right, pull that in. And so we are here. So what we're going to do is we're going to move over here now. Go to the opposite side of this supernova remnant. And this is going to show you, you'll see now when it starts to move. Mm-hmm. We're going all the way to the other side now.
That is so awesome.
It is. It is. And here is this arc. So we're going to...
see it.
Yeah, you can see it. All right, so what we'll do now is we're going to move to the west a little bit. Center it up.
Mark, how often do you have to collimate it so that it stays where you want to search through Stellarium or whatever program you're using? It's accurate, you know what I mean?
Yeah, you mean align. It's not collimating. Collimating is different, but you mean alignment. The alignment, I do it every time I get in for the night. And so right now, we are good.
Cool.
Yeah, because I told it to come here from where I was before. So what I'm going to do now is I'm going to come up here. I'm glad you could join tonight, Bill. That's great of you to set aside some time to join us.
Well, I said earlier that if you went live, I'd join you.
Yeah, well, I had to leave it up to you. It's fine if you had time. All right. So now what we're doing is, you'll notice here it's searching. It's going to find a guide star. There's a second telescope on the back of this guy here. In fact, there it is. You can see it right here. This is the second telescope on the back right there. And that telescope is the guide telescope to guide this main scope. Okay?
Wow.
So that's what's going on. And this here doesn't need anything more than a 25-second exposure either. All right? So we're going to do that now.
And hello to everybody in chat, by the way.
Yeah, it's great that people show up. I mean, they populated quickly tonight. There was as soon as they started, it was like, bam, people coming in, you know. So here is the right-hand side, or the western side of this, okay? And now we're going to see the eastern side. I'm going to clear it because the eastern side is going to be brought in right now. You'll see it come in. And there's the eastern side. Look at that.
Wow.
All right, and we'll color correct. It's pretty close already, but the colors are just stupendous. And now let's process to see where it wants to go. It's going to do that. Yeah, I figured. There's a lot of noise in it now because we only have one frame, but once we get a second frame, you're going to see that this is going to look clearer all of a sudden. So keep watching. Here we go. Okay, now it already started getting clearer. Look at that. This is pretty cool. All right, now let me just drag my processing windows over just to make it a little darker. So here's what's interesting. Okay, here is the entire nebula. But from this side right here, this looks like a nose.
It does.
It looks like a mouth. In fact, this looks like Alfred Hitchcock from the side.
Does. I was going to say that. It looks like Hitchcock.
Yes, Alfred Hitchcock. Yep. And again, notice the tendrils down here. Those tendrils are really interesting because it's possible that electric currents are responsible, because it's a very, very, very rarefied or thin, less dense medium out there. But it might be enough that electrical charges can flow amongst particles and cause the shape of the nebula to be determined in part. And that could be what we're seeing here.
Is there a commonality with other nebulas that have the same type of pattern?
There is, yes, indeed. There's a commonality. There are nebulas that do seem to share the same type of properties.
Mm-hmm.
Yeah. Isn't that cool?
That is.
Yeah. And now, this is the other side of that other one that we just saw. All right. And there's one in the middle. That's the central one. And it's called the central veil. Now, that one could be coming at us. It could be going away from us, or both. But from the front, this all looks the same to us. This stuff, whether in the foreground or in the background, we can't tell which tendril is closest to us or farther from us unless we study it for a long period of time.
What about the James Webb? Is there something that you could focus on?
Yeah. In fact, the James Webb has looked at some of these nebulae already, like the Pillars of Creation, the Eagle Nebula, Messier 16. And it showed some interesting details in there, stars that were not seen before. And Ronald's asking a question, what is the green and red? Thank you for the putting it in all caps so I could read it. The red is hydrogen gas. Remember the order of events in the universe. Hydrogen is the most populous element in the entire universe. Okay, there's more hydrogen than anything else.
So, before you continue, would that be a great asset to have in space for propulsion if there was such a drive that ran on hydrogen? Where you tap into those sources, since it's
if there was such a drive, then hydrogen would be available everywhere. But you would have to collect an awful lot of it to be able to use it. And in a nebula like this, okay, you can see a lot of this red hydrogen here, right? And you say, oh, that must be dense. Actually, if you got there, you would sail through it and not even know you're in it, okay? Because on Earth, you have maybe 10 to the 19th atoms per cubic centimeter of air. 10 to the 19th, okay? But out there, at most, you have 30,000 atoms per cubic centimeter, not 10 to the 19th atoms. So it's very, very thin. So, but from a distance, a long way away, in this case about 1,800 light years or so, the long distance promotes this look like you're looking at a very solid looking object. Now, to Ronald's question, this red is hydrogen, and again, hydrogen is the most populous element in the entire universe. Next one is helium. Helium is the next most populous element. And then the next most populous element, believe it or not, is oxygen. There's more oxygen than there is any other element other than hydrogen and helium in the universe. And when you ionize oxygen and you knock off 2 electrons and ionize it, doubly ionize it, you get a green glow. Okay, the process fosters a green glow. All right, so we see oxygen and we see hydrogen. So this is why many nebulae are red and many nebulae have green, because they're glowing elements of the most populous elements in the entire universe. So we see that often.
So with that combination, that can cause an electrical discharge, like the explanation you said earlier with these strands that seem to be connecting, and there seems to be some type of activity going on in them.
It's possible, yes, because if they're ionized, the atoms of material, like the oxygen atoms, let's take those. You knock off 2 electrons, okay? And now you have a nucleus of the atom that's sitting there, but it's charged. It has a charge on it, okay? And in the simple terms, with the hydrogen atom, you ionize, knock its electron off, and now, instead of a neutral charge, you have a +1 charge on that nucleus. That's a charged nucleus. It's electrically charged, okay? And the electrons are negatively charged. So you could have interactions with the interstellar medium, the dust and the gas, that could promote interesting interactions that promote spindling of material out there and gas. All right, and this is one of the fledgling sciences that they're looking at right now. It's possible that electrical charges in these nebulae are more prevalent than they thought.
And I still look. I see Hitchcock. Now that you said that, I see Hitchcock.
And it shall continue.
Oh my gosh!
So here, let's just try. Let's knock off a little bit of the noise here. I'm going to come over here and knock off some of the noise. Okay. And now, if you notice, when we zoom in, you'll see that there's some areas that are brighter than others, right? Like this is an area that's interestingly bright, and it looks like it's being crossed by some nebula here, okay, that's also hydrogen-rich and glowing red, all right? Then you come up here, and you've got these bright tendrils like this, right? Now, these stars that you see here, many of them are up here in the foreground, and the nebula is back here. But you also have stars behind the nebula as well. So it's a 3D universe, remember. So they're all between here and close up and far away. And the nebula is a supernova that occurred in the middle of it all. And that was from a star. One of these little dots created this whole thing you see here, and the other one we saw, and the middle one we have yet to see.
Is there any evidence or indication how long this actually would last?
Well, that's actually a very good question, because as we look at a supernova like this, the supernova remnant, sometimes they are self-perpetuating in the following way. As the material is going out from where the blast occurred, it's colliding with stuff, other gas, and it can heat that other gas up to millions of degrees from these collisions. And when it does that, it'll cause ionization, like we see here. Some of this gas may come from the progenitor star. Some of it may come from the interstellar medium. There'll be a mix of the two. So it's possible that this nebula here is a combination of interstellar medium gas that's being ionized by an outgoing shock wave, and the outward flowing material could be ionizing itself as it's going out.
So could that collision continue to give it the activity, in theory, with the electrical charge?
Well, the ionization will cause the particles to become charged. All right, and the Veil progenitor star, the neutron star at the center of all this, is actually the one that was originally the ionizer for all of this. But as it gets far away from the star, other processes take over, and so now you can have the stuff's perpetuating because of its motion. Now, over time, that stuff will slow down, and this material will eventually go dark. Okay, the gas, the hydrogen gas, and the oxygen will eventually recombine with their electrons. Temperature will be cool enough, and it'll just be oxygen atoms and hydrogen atoms out there once again. And if something happens at some point, then they can be caused to glow again, and maybe the nebula will look very different by then.
Interesting.
Yeah, it's really cool. And the supernovas are scary if you think about it, because if we were within, say, 30 light years of a supernova like this one, that would spell the end of the Earth. You know?
Wow.
Luckily, that won't happen. Okay, so we're at 25 here, and this is going to be, this is known as the Eastern Veil. So we're going to call it Eastern Veil Nebula.
Okay, wait, before you keep going.
Okay.
What is the color of a star before it goes supernova?
Oh, that's actually an easy question. Because there's only a few limited choices. The color of a star before a supernova can be red, a red supergiant, okay? Or it could be a bright, hot blue star. And there's a couple ways that can happen too.
So if we look back in time, let's say 50 light years or 30 light years around planet Earth,
Yeah.
and we're looking back in the past, obviously, we're looking back in time, could that be something that we can say, well, this is one we have to watch because this is something that happened in the past, and it could potentially be a supernova for our future, if that makes any sense?
Well, it kind of doesn't, because I'm maybe I'm not following you.
All
But
right. So
yep.
say you see a planet
Okay.
10 light years away.
All right.
And how many years would a star be if we're looking at it 10 light years away? Would that be in our past?
10 years.
Okay. So
if it's 10 light years away, it's 10 years that took the light to get here.
So if we seen a planet that fits that criteria,
Yeah.
and it's looking back 10 years, right?
Okay.
Wouldn't that be an indicator if we saw something 10 years ago that might be a concern because it looks like it's entering or near the supernova phase?
Well, we do have to be careful about the supernova, obviously, because there is danger to us from a potential supernova out there.
Right.
But none of the stars in our local neighborhood, nearby neighborhood, and those that are coming toward us
Okay.
are candidates for supernova.
Okay. That was the basis of my question. Okay.
I want to say
So
hi
we
to...
have no concern in the near term future.
No. I want to say hi to RJPX. He says, I don't see Hitchcock. I see a leering grin in that patch of nebula coming off the bow that's like a goblin, ghoul, or undead, etc. You watch too much Walking Dead. No, but I do understand. Is this the leering grin you're seeing right here?
It does kind of
then,
look like
and the nose there, and then eye sockets for a zombie eye. I mean, yeah, it could be. And a bald zombie. Yeah, I mean, yeah, could be. Could be.
Oh my gosh.
So RJP, that's not bad. Hi Gladys. Gladys one is with us. Hi Gladys. Okay. Renee Cruz says, San Francisco, 1978. When I was 12 years old, I saw an extraterrestrial, alien, metallic, octagon-shaped UFO, starcraft, and sparkling shooting star. My family ghosts at cemetery, cemetery. Mind-boggling. I'm flabbergasted. Wow.
So she's seen her family's ghost at a cemetery, I'm assuming.
Okay. Interesting. Yeah, I had some weird events like that. In my shop, I had something happen. And I'll mention that in a second. I'm gonna save this one more time. Save it exactly as seen. Okay. Yep. And now I'm gonna zoom in on it one more time. Let's look at this. Check this out. Ready? Look at this. Look at this incredible. This is just. And you know what's interesting about this is that this is the universe live in real time. That's what we do. This is right here in front of you, taken just now, and you watched it happen. So this is what's over your head, the stuff no one ever gets to see.
Mm-hmm.
This is what's over your head. Now we can come down here and look at this little interesting set of tendrils here. Really pretty. I'm just finding that to be fascinating. Wow, really good.
Pretty massive too in size.
Yeah. Okay. I always hate to get out, but I know the image is saved up online, you know. But we'll save one more time anyway. And save it exactly as seen. Okay.
And Izabela put the link to the images from tonight.
Yeah, she's great. Did you see her introductory video to our streams? And did you see any of the Instagram or Twitter or TikTok?
Oh, but I'm going to check it out.
She has done a marvelous job. She is a really good artist. And let me tell you, if you had her on your team for anything, you know, give her a job at KGRA, all right? And pay her. Okay? She would love a good paid job. She doesn't now. She's pay. But you got work. You have Izabela consider it, because she really knows what she's doing.
Coming through, that's one heck of a, you know.
Yeah, no, she's really good.
If you say it, I definitely believe
well,
it.
if you just go look at the quick videos she's put out there, okay, from our stream, she's put together videos. Unbelievable stuff. I watch them and I'm entertained by them. And I said it. I'm the one talking. And I'm still I'm entertained because I see what she did, you know.
Uh-huh.
Sorry, Izabela. I know that maybe embarrasses you, but hey, too bad. If you're good, you gotta suck it up, right?
Well, you know what? She
Yeah.
can definitely. She
Oh,
can
yeah.
definitely a 30-second ad for your commercial set for SkyTour live stream.
I think that's true. I think that's true. All right.
Isabella, I'll just say it right here. If you can make a 30-second promo that I can put in an ad set during his commercial break, please do, and then send it to me, and I will run it on the station. There you go.
All right. If she wants to, she can. All right, we're going to move to the central veil now because I want you to see this. This location is the dimmest part of the nebula, but as you'll see, it's going to be the most interesting part of the nebula. Pickering's Triangle is here. It's a really incredible location. And I'm going to, I think it's right here. I'll have to see. So what we're going to do is we're going to do another 25-second shot here. And now you're going to see the thing that's coming toward us or away from us, or a mix of the two. All right, we saw the outside edges of the stuff expanding outward. Now we're going to see what's going this way. It's roughly a sphere, you know. Roughly. All right, so. Izabela says, I want. Thank you, Bill.
Yeah. Make it happen, Isabella. We will.
Oh, yeah. Well, she certainly has a lot of source material to do it with, I'll tell you. You know, Izabela, you could actually take the ones you did and just put them back to back.
For real.
Yeah. All right.
I'm sure she'll tweak it and get it done.
Oh, I know. I mean, trust me. She knows what she's doing. We have very talented people that watch this stream. You know, I particularly appreciate hearing how people make popcorn and sit down and turn this on like TV. So there is the Eastern Veil.
Actually, Mom is watching you on her TV. So, yes, people do watch this on their TVs, actually, Mark.
Yeah, I think Cosmic Ray is doing that right now. Yeah. All right, so we have 5 seconds until we see the central veil here. Should be about where it needs to be. I don't think I have to move it, but we'll find out. Look at that. Okay.
Oh, wow.
Yeah, as it is, I got to move over a little bit, so I am going to move it over a little. Just a tad. Sorry, guys. But you'll be okay with this. All right, I'm going to move this over just to here. So we're going to head west a little bit. All right. And that triangle of material you saw there was Pickering's triangle. Really interesting stuff. Okay, now I'm also going to drop it a little bit. Like that. All right, there we go. Now you'll see over here, it says searching. That searching, it'll sit there and show numbers and then start guiding. And that's when we actually will start doing our 25-second exposure.
By the way, Sam S. says, I only watch on TV.
That is very cool.
So there you go. And RJPX says, yes, I make popcorn, pour some wine, maybe open a cold beer, and settle.
Yeah.
Probably shut the light off, because that's the best thing for this. In a nice dark room to see this, oh my gosh.
Oh, yeah. And the thing is, we do it at a higher resolution. Let me bring up our live stack here.
A lot of people are watching on TV. Anthony says he's watching on a 77-inch, so yeah.
Oh, wow. That's fantastic,
Can
Anthony.
you imagine? That has to look, I don't want to say it bad, awesome.
Yeah, but, they can see all these. They can read all the detail on the screen. It's not, everything is there,
Though, even on a phone, the sharpness and the details comes through, Mark.
Does it?
Oh, yeah. I've actually,
cool.
That's how I found out you were live tonight. I was watching you on my phone. I said, whoa. And it looks good on the phone. It doesn't have to be a giant screen TV, because it looks pretty much everything.
So,
Mary Ann's in the house.
I was just going to send her a message saying, hey, we're here. She must have heard people talking. Hello, Marianne. I was talking to her earlier. As you know, we are a 501c3 organization. Marianne, in fact, is the chief financial officer for it. I'm the CEO of it, and Tara Diulis is she's our secretary. But there's another. We're changing the title too because she's got pretty heady responsibilities. So this is cool. Look at that. All right.
Awesome.
What?
They're both equally awesome.
Oh, I know they are. Marianne can be seen on her show I Detective. And Tara can be seen on SkyTour Radio and on What's Up? MUFON.
Yeah.
Yeah. Old school. That's Leon. He says, and here I am just sitting here with my little 32-inch LED. That's okay. You want to know what I got? Yeah, you're probably wondering. It's actually a curved screen, okay? And it's actually my son's old screen. I still owe him money for it. I have to buy it from him, and
I'm watching it on the 32-inch myself. It's one of my monitors.
Oh, very cool. Yeah, you are. You have a setup for the radio station. By the way, in case you guys don't know, the guy on the phone with me here is Bill Skywatcher. He is our producer for KGRA for a whole bunch of shows. You can tell by his passion that he's into a great deal of science type stuff. And SkyTour Radio on KGRA is one of the few places you can go to actually get some real astronomy, on a Sunday night, 6 to 8 p.m. Eastern Time.
Yep.
Hello, Anthony DeSanto. How are you? Yeah. Anthony DeSanto says, it looks incredible. The one thing about OLED screens is you have the blacks that are rich and the light areas don't interfere with the black portions. That's right. What were you saying?
No, Ronald's funny. He's just too much.
What
he says, hey, do I have to make another donation for Bill's wrench? Listen, I'm kind of a newbie here. I need to earn the wrench, Ronald. You know what I mean?
Well, that's right. You ain't getting no wrench. No, I'm just kidding.
I'm
obviously I'm kidding. Yeah. Well, actually, the way you always if I go to say something, you finish my sentence and blow it. You let everybody know what the heck I was about to say, and it's like, hey, yeah. How many times have I chased you out of the room?
Oh, but at Roswell,
literally chased you out of the room.
No, but at Roswell, when I was interviewing Marianne, you threw this right before we were doing it. You threw this freaking UFO rubbery thing at me.
I did.
So,
and you know what? As it left my hands and sailed through the air, I said, "Vindication is mine, and revenge is a dish best served cold." And boink, this foam rubber thing bounced off you.
I got to get revenge on Marianne. Speaking of revenge, I got to get revenge on her.
Why?
They set me up in the road. What was it, Texas Roadhouse, when we were eating, and I knew something was up because she almost gave it away when we walked into the restaurant. Something she said, and I'm like, what the hell did that mean?
Yeah, she can't. She's not good at keeping secrets. You're gonna have to. You don't. It doesn't take much to get them out of her.
And they made believe it was my birthday, and I see a saddle coming up to the table, and this woman comes out of nowhere and says, "Yeah, I'm gonna scream really loud. You got to sit on that." I said, "What?" Oh, it was great. It was great.
It was funny.
It was great.
Yeah. Well, that's people only do that kind of thing for people they like. So.
Oh yeah. Well.
Yeah.
And then us in the car, VLA. Oh, that was too funny. As we're approaching the very large array.
That's right.
Mark and I are cheering it on, let's go.
And Marianne was driving. She's going like this.
Yes.
Oh
my gosh.
Yeah. VLA. And as soon as we saw the first dishes, we were like little kids, wanted to hang our heads out the window and go, "Look at that!"
That was great.
Well, you know what? The VLA has made such incredible discoveries that it's worth doing, and it's a Y-shaped array of radio telescopes, and they can bunch them all up close together, or they can move them really far apart. And so you get the best resolution when they're really close together, but you can see the more detail the farther apart they are, because you effectively increase the size of your telescope. So it's really cool how they do it. It takes a few days to orient the antennas because they're not on motorized bases. They're actually carted around by a little train wheelie dealie that moves them around, puts them on a siding, it's called, and then locks them into position. That's no small feat to orient these arrays. So it's pretty cool. Look at that. This is the central veil now, and what you see is this beautiful gossamer filaments down here. Okay, and you'll see hints of it elsewhere. You see hints of other stuff. There's a lot going on here. There are many stars in this neighborhood. Okay, and so this is really, really a very, very dense area with stars, you know.
By the way, Mark,
Uh-huh.
Michael's birthday is coming up October 21st, so an early happy birthday to Michael.
I mean, 24th.
He said the 21st.
Uh,
My birthday is October 21st.
oh, okay. All right. And then James Dugan said, happy birthday on the 24th at Michael Galea.
Well, happy birthday, Mike.
Yeah, and then Michael said, my birthday is October 21st. Mine was October 17th.
Yeah.
Yeah,
Happy
just
birthday,
2 days
Mark.
ago.
Yeah.
Look at this beautiful stuff
That
over
is
here.
gorgeous. That is
That-
gorgeous.
This is gorgeous stuff, you know, and it's interesting to think this is fleeting. It's going to go away when the ionization is done, or the material starts to slow down from collisions with the interstellar medium. The glow is going to vanish. Every glowing nebula will eventually go out, which is interesting.
Yeah, but new ones appear, right?
Yes, and if you form new stars in those nebulae, these stellar nurseries, then yes. The thing that happens is, though, that when stars are formed in a stellar nursery, which is not this is a supernova remnant, but when stars are formed in a stellar nursery, it glows. The Orion Nebula is a stellar nursery, and it glows. But the more stars that are formed in the middle of that, like the Rosette Nebula, the more radiation pressure they have to push material away, including dust and other gas. So what they tend to do is clear out a space around them. Okay, officially we call it a cavity. It makes a cavity around where the star is formed. And when it does that, well, it's moving away material from which new stars could form. You know?
Uh-huh.
Yeah.
Yeah, this is another one I'm sure you're gonna do clip save.
Oh yeah, I am. That
definitely has to be saved.
Oh yeah. Well, we save them all, unless the guiding stinks, you know.
Mm-hmm.
But tonight the guiding seems to be okay. If there's
And the
wind
Webb
out
must be
there,
no?
it's exceptional out there, and we're pointing almost straight up, so it's pretty cool. So we have 21 shots here. We'll go to 22 and save it there. Very cool. Ronald, thanks for telling us who's going to be on your channel tomorrow. It's good of you to do that. I love it when you do that.
He does it with me too.
I know. I'm fine with it, actually. And I meant that when I said.
So, yeah.
All right, so we'll save this now. But you know what? You know exactly what happened when they said that. At his end, you would have heard, you know, he would have laughed.
I can hear it. I can
You can hear
it in my
that
head.
laugh, yeah.
Oh my gosh.
Oh, yeah. So here's what we're going to do now. We're going to zoom out, show you the whole thing as captured. There it is.
Nice.
Now, let me go over here to that other. This here is called a histogram. This is called a histogram. But let's go to this one and do a global punch just to see what else is hiding back there.
It's funny because there's
Look at
still
that.
There's a little slight green on the left side of the screen too.
Yeah, right here, and right here, and look at that.
Yeah.
Look at that that little filament right there. See it?
Yeah.
Now, if we take off our hyper process, okay, and come back over here, we can zoom in on this little tiny guy over here.
It's amazing though when you see all the stars in the background too.
I know, or foreground, but see, this is one filament right here, sitting right there. Where'd that come from? What's it doing? What would it look like if we were there? How thick is it? The little tiniest element you're seeing there is bigger than the whole solar system in width, right? So that shows you how big these things are. You know?
Mm-hmm.
Yeah.
Well, Bob, happy birthday to your wife on the 20th.
Hey, C&D boy. Nice. C&D boy, he comes on sometimes and then he'll say that I'm on the TV again every day up there.
He's just trying to prove it to his wife that he's not doing anything to get in trouble.
Oh, that's funny.
Oh my gosh.
That's funny.
See?
I heard from A&E today that they're coming out to film again in December. And that'll be the third of the 4 film dates that we have. So the show is very popular.
Good.
Yeah. So I'm really happy about that. It's a good show. I won't agree to do any shows that are crap shows, you know.
Huh.
Yeah, if anyone's listening in Connecticut here, on the 25th, I will be doing a talk at the Plainville Library. I grew up in Plainville, Connecticut, and I said I would do a talk for them. And then on the 27th, I'm filming here with Tom Reed and Rhiannon for his show. And then on the 28th, I'll be in Danbury, Connecticut, doing a talk. And we're going to talk about the physics of interstellar travel at a lay level in a way that you can actually see how it could actually work.
I don't know if I'm going to say it here, though, but Tom and Rhiannon, I'm on the Sky Tribe team.
Excellent. I got the T-shirt.
Yeah, so the crew shirt, but I am actually going to be, and KGRA are going to be more involved with Tom Reed, Rhiannon moving forward in the future with future projects.
Very nice.
So
wow.
We're all that family. You know how we're all connected. We are.
Yeah.
It's funny how it branches out, Mark, because like Toby is, you know Toby.
Of course.
He's writing Tom's book, and this is connected to this person and that person. It's like, wow, it's like really super cool.
Yeah. Look at that beautiful object. Okay. We are now going to go to our next object. This stuff has been saved. It'll be up on the database, on the server rather.
Yep.
You know. And by the way, C&D boy, that's Bob, right?
Yep, Bob.
Yeah, Bob, congratulations, Grandpa to be.
Oh yeah.
That's really cool. I'm only a grandpa to a dog right now, and I'm happy about that. Okay, let's bring up our wonderful stellarium. That's the Filamentary Nebula. That was beautiful to go to. But I want to head more north now because I want to do something different. Well, not different, but something we haven't looked at lately. And that is this beautiful nebula right here. This is called the Elephant's Trunk. And what we do, and the reason we're looking at the Elephant's Trunk, you watch the telescope, you'll see it's going to head looking that way. It's going to be looking that way because it's that way over there. It's going to be checking out this object here that's really fascinating. It's not really that bright, so I want to see if I can locate it here. Let's do this. Okay, it's right there. Okay, so I'm gonna move west here, like this.
It's still so cool that you could be sitting at your home in Connecticut
And moving this telescope 2,000 miles away. Yeah.
and also thanks to Marianne and Tara for what they do.
Oh,
as
absolutely. Yeah. Without them, none of this would be possible. You know? That's why I say, you know, the I in SkyTour was quickly replaced with we. You know? There's no I in this, you know, anymore. And I'm okay with that. They deserve all the credit that... And I give them credit all the time. Okay, let's do this. All right, we're gonna do that. All right, this. I think we're gonna be looking right here. So let's just drop it a little bit like this. Okay. Based on the stars, I think we're just about centered with our object we want to see.
well.
Called the elephant's trunk. I think I'm correct on that. But if I'm not, we're going to find out for sure. Again, another 25,000 millisecond shot. There's 1,000 milliseconds in a second, so 25,000 is 25 seconds. Okay. So let's get out of here. We're doing our thing. Go into our live stack. Central Veil. I'm going to just save that one more time anyway. Because I got it labeled as such, so we'll just save it. Alright, and now clear. And this will be Elephant's Trunk. That certainly doesn't look like the elephant's trunk.
Not yet.
Not yet, correct. Oh, but that does right there.
Wow.
Yeah.
It does look like the end of an elephant's trunk.
It does. Now what I'm going to do is position it just a little better. I wanted to get it so this black region was visible. It's actually quite visible. So what I can do is I could just, I knew that's about where it was. Okay, so we're good with that. So what I'll do is I will get out of this and quickly reposition. I knew I had to bring it up a little bit, but I didn't go up quite enough. All right, so let me bring it up.
Is that red really there, Mark? Or
Oh, yes. Yeah, it's really there. We're looking at ionized hydrogen gas in this region and lots of dark dust. Okay, so let's do this. All right, now other thing I'm going to do while I'm here... Oh, yes, you are. She's going to Utah tomorrow.
Ogden, yeah?
Yeah.
Should
Yeah.
be hanging out with my boss.
With Warren.
Uh-huh.
Yeah. Okay. And let's drop this down to 200 again. There we are. All right. Now, what I want to do before we do anything else, one more little thing I want to do is what?
I'm muting for a second. Mom's still
Okay.
Stand by.
Beware of Mom. All right, we're going to do a shot here to see what our night sky looks like.
Well, that's good news.
That's good news.
Stewart Airport is going to have more airlines in the near future, which is...
That's really good.
Oh, my gosh. Will that be a blessing?
Oh, shit.
All right, Ma, we're live. Say hello to Mark.
Hello. How are you, Ma?
Yes, Mark D'Antonio. Anyway.
Okay. All right,
Sorry.
so yeah, that's okay. I see what we're doing here. So I'm gonna go back to 25,000 milliseconds and zero that out and go to our stack again. And now, what we're gonna do now is we're gonna notice that this thing is over here now and a little higher. So we're gonna center that up a little bit more, so you'll see the elephant's trunk a little bit more.
Centered.
Yeah. Cosmic Rays. Anybody out there got a spare LX200 motherboard? Yeah. I'm well aware of the problem, Ray. Unfortunately, the LX200, when these older Meade scopes go, there's no replacements, and that's because the company went bankrupt.
Wow.
Yeah, there we go. There is the elephant's trunk and the what's called the caravan. All right, I am going to get our curves lined up here. You can see the subtle changing colors. And now I want a little more latitude to explore and process. So I've fattened up my curves. And we're going to take this guy right here. This yellow bar here, understand this is the data from the camera. The red, green, and blue. The white curve is the average curve. Okay? Yeah, I know. All right. And so, what I'm going to do is slide this over to increase the brightness, the intrinsic brightness of the details. Then slide this over the other way to climb that white curve to darken the background.
Wow.
Okay, and what this will do is allow us to get the best view of the object. See how that's coming out now? And that's with only 4 stacked shots right here. You can see only 4. Yeah, 4 right there. See? Right there. So that's all it is.
And that is hydrogen?
It is. And this, for instance, this is actually a dark nebula. Okay, this is dark dust. This is tendrils of dark dust that are sticking out here. And there's hydrogen mixed in that's being ionized. And it's silhouetting some of the dark dust that is within it. Because there's other gas around the outside. So it actually looks like it's highlighting it. Yep.
It almost looks like there's light behind it.
That's correct. That's correct. Yep.
That's stunning too.
Oh, yes.
And how far, Mark, is this? Light years?
I'm not sure, but we can find that out. At least get an approximation by going while this goes. So you can go to our elephant's trunk.
It's just amazing when you think that you're looking at this with the clear imagery and it's light years away. It's just unbelievable to think that you can pick something out so far and so clear and crisp.
And
obviously, your cameras enhance it, but
yeah, and okay, in a bit you'll see what's going on in here. Remember I talked about that cavity that stars make when they're formed, and they actually blow out with such radiation.
I see that.
Yeah, you can see that there's a hole here inside this dark dust.
Yeah, like round circle. Yep.
Yeah, well, that's actually a cavity created by the hot young star that's in here, or some stellar process going on in here. So yeah, so you can start to see some more details showing up in here, and that's gonna get even more exciting. So this is shows you the rippled structure of that area over there. It's pretty interesting. It's like a rippled look, and I just think that's incredible.
So I'm sure when you say that, there's got to be planets and moons probably in the early stages of formation around that young star as well, right, Mark?
Maybe not. Depends what kind of
early?
star it is. Oh, well, it depends what kind of star it is. Depends on what stage of its evolution it's in, you know. But it's possible. It's possible. I want to say hi to Petita. Petita's in the chat.
Petita.
That's PG.
Yep.
That's Pennsylvania Petita.
Yes, and Woody.
Yeah. Pen Petita. Yeah. So I hope you guys are enjoying this tonight. Hello, Carmen. Nice to see you. Thank you for dropping by. I remember Carmen dropping in earlier.
Actually, she just recently got engaged.
All right.
Congratulations to her.
Wonderful, Carmen. Congratulations. Here, let's actually drop this down, and let's get rid of the telescope here, and show you what's going on here. I'm gonna be able to zoom in now, so we can actually do this full screen, because this is a beautiful nebula. You know, and here we are in our spaceship. Doink. Oh. So this dark nebula, you say, well, where's that all come from? Where's all this dust come from? And the hydrogen, well, hydrogen, again, fundamental element that makes up the universe. It was there from day one. Some of it's been liberated by supernovae. But all this dark dust we're seeing came from previous stars that obliterated themselves in the same kind of explosion that created the Veil Nebula that we just finished imaging.
Wow.
It's incredible, yeah. Yeah.
Is that? I mean, there's got to be a balance. There's got to be a law of averages here. Is this something that you see commonly? Because it has to be something that goes through the evolution of stars and the destruction of stars. It's a cycle.
This is a cycle. It's a common thread in the universe. Yep. Very common thread. We see star life, star destruction. Yep. All right. And so here you can see this now a little bit better. Right. So there is our elephant's trunk right here. You can see this spindle dark nebula here. And again, it's mixed with hydrogen. It's partially obscured in its ionized form by the dark nebula. All right. Zoom in on this a little more, and you can actually see the interior here of this circular trunk. It's illuminated in there by this star. Really fascinating stuff. Wow.
Is that around the yellow center of the young star? Could that be? Because it almost looks like it's spinning and it's causing like some kind of activity going around the young star. Like,
you mean here?
Yeah.
That's actually a second star in there.
Is it?
Yeah, it's a second star that's in there. Or it might be deeper into the cloud behind it, or it could be in front of it.
Right.
Yeah.
It's hard to tell.
It is hard to tell. Yeah. Let's see if we can figure out where it wants to be. Okay, so this is where it wants to be process-wise, right? But it doesn't mean it has to be there. I like bringing this in just a little bit. Okay, like that. All right, so we have done 19 stacked here.
What do you usually go up to? 22 on a stack?
I'll go between 15 and 50. Depends on how fast we're shooting. The other night I shot the double cluster, and I think it went to 46 or even 52. And it didn't have to, but I was talking about it. Okay, this is nice.
Another save soon.
Yeah. Okay, there's 21, so we'll save that. And save exactly as seen.
All available at SkyTourLive.org.
Yeah, SkyTourLive.org. Yeah. Yeah, indeed. And you scroll down and it will show you very clearly where to go. And if you want to buy products that have these objects on them, you can go to SkyTour shop at Etsy up there. See it? There it is, right there. It's in the red. Yeah. Yeah. And SkyTour shop, we have almost 100 products up there. And more coming. And you can get coasters with our things on it. You can get blankets, shirts, bathing suits, believe it or not, and all manner of office-related gear, mouse pads, etc. And so a lot going on. So I think that we probably could focus this a little better, which would have made that star appear a little more easily. But that's okay. So what I'm going to do is I'm going to bring us back here. So redock that and get the telescope back again here. And now I'm going to save it one more time. Actually, wait for the 25th shot to come in over there.
So are you going in? Are you going to zoom into that star? Or are you just making it more with clarity?
I'm going to try to.
Clear it up.
I'm just going to try and. Well, I'm going to run through a focusing. I'm going to run through a focus run, and I'll do that now, and then we will move on to another object, because I won't make people sit through this one again, but it really is very beautiful. And it's something that you won't see. You just won't see it.
The thing is, Mark, everybody's so familiar with the pillars and some other images.
Yeah.
People don't realize there's so much beauty out there.
I know. All right, here we go. So what I'm going to do now is run through a focusing run. People have seen this before. You know what's coming. So what happens is the telescope is going to try and focus. And the way it's doing that is it focuses, it measures the size of the star image, and you'll see the curve right there make a parabola, make a curve that's this shape. And the lowest part of that curve is the lowest, smallest size of the star image. So this will autofocus for us, and then we just tell it, go to that focus position, and it'll automatically focus perfectly. So it's from out of focus to in focus perfect to back out of focus. And once it does that, as it reaches near the end of the focus run, it'll have found the right focus, and it's going to put a line in there for us. And that line isn't going to be at one of these exact points. It's going to be wherever that lowest point is mathematically, which looks like it's going to be right here. So in just a second, you'll probably see a line show up right about here at this low point. So see this guy? It's going to be showing up right around there. Watch. Okay, so it's not going to be exact. There it is. So
Almost,
yeah, almost, yeah. But that's mathematically the lowest point. Okay. So we can tell it to go to best focus right now, because that looks like a good curve. So it's going to do that, brings them back out of focus either way, and then right into that spot where the focus is the tightest. All right. So there we go. There it is. All right. Now we're just going to do a quick 25-second photo. And I'll remind you of what we're looking at before. Okay. So it's going to be this guy, and you see how that looks in there?
Yep.
Okay. Yep. All right. So let's clear that and wait for this next one to come in, and you'll see how the stars are going to look now. All right.
It does look like a second star in there, Mark.
It is, as you'll see. Okay. Now you can see that second star very clearly, and after the second image comes in, a lot of this colored noise you see here will go away, and will make it really show up a lot brighter. So focusing was important to do. Probably should have done it before, but that's okay. All right, so now Just watch here. Here we go. Watch now the noise drop. See that?
Yep.
Now you can clearly see that second star in there right next to
Yep.
this first one.
Yep. Yep.
So it's a matter of focus. All right, so we will color correct. And then actually correct. So now
So
it's very
three
clear.
possibilities. It's part of that. It's either behind it or in front of it. Those are the three possibilities, right?
Yeah. That's right.
But it sure looks like it's near that one. I don't know. It
Could be.
Like you said, it's hard to tell.
It could be, but I think this star is the one that's clearing the cavity, and this one might just be like one of these stars in the dark cloud that you're seeing, and it could be behind it probably. And most likely that's one of those little red dwarfs, you know.
Mm-hmm.
But there you go. So now we're in good focus. So what I'm going to do is I'm going to come over here and see if we can do one other thing, which I know we can. We're going to go to another object that really shows well. I won't redo this one because on another night I might. Okay, but not tonight because I don't want you to have to run through this again. Okay, so here we go.
Did you save that?
No, not. I saved the previous one.
Okay.
But this one here wasn't enough. I didn't have enough stack layers to save very well. Okay, but now that we're focused, let's go run down to the Iris Nebula and check it out. So here we go. Telescope's gonna go spinning now. Look at that. There it goes. Yeah, we got 400 pounds of telescope moving now. There we are to the Iris.
It's so cool to see it running right above your head. It's moving. It's so awesome to see
I
that.
gotta get out of the way. I don't want to hit me in the head. Yeah.
It's so cool.
Yeah, this is the Iris right here. And you'll say, how do you know? Well, because it has a little fuzzy around it, and that's actually the Iris Nebula. And it's funny is in a telescope, you see only a little bit more than that. You know? So I'm going to move it over. And I'm going to go south a little bit. Just send it back up. Move the telescope south. Okay. And if it stops there, that's good. Yeah. And we can increase to really, really high. And now you can see the shadow there. You can see the nebula. All right. So we're going to go here. We'll go to 300 just temporarily. I'm not going to stay there. But you can see the nebula. So we're going to go to 200 again. Now the best views with this camera are at 100. Okay. 200, a little higher. In other words, the least amount of noise is at 100. But I'm going to do it this way because at 200 you'll see more data. Okay. All right. So this one is going to be a 35-second shot. All right. So it's off and running. And we're going to go into our live stack, get rid of that last. Well, you know what? I'll save it anyway. It's only a few. It's only 4 exposures, but it's actually well done.
Yeah, it looks crisp to me.
It is. So we'll just save it, and then we'll clear this. All right. So now with that same focus, now here's what happens. Okay, when the telescope's aiming this way, and you focus, that's one thing. But when the telescope lifts up and does this, okay, now the mirror can move a little bit, and that causes something called mirror flop. And so to avoid mirror flop, you refocus. All right, so that's so there's the Iris. Now this is an area that's absolutely incredibly rich in dust and dark nebula. So hopefully we'll get to show you that. Let's bring this up. Okay, you can already see that something's going on here, right? And if we move this down, you can see that there's something else here, right? Well, there's a lot going on in here. In fact, there's stuff here, there's stuff up here, there's stuff out here. In fact, this whole region is filled with brown interstellar dust, carbon molecules, carbon, and silicon, and other dust that's coated liberally with ices, methanol ices and carbon dioxide, water ice, ammonia ices. So there's a lot of different types of ices that are on these particles of dust. And in other words, once a star forms in there, it melts those ices, and now that is a slurry of planet-building material that's now available. Now, here's what's interesting. If you look at this right here, Bill, you see that shape right there? You see how you see stars in there? And you don't see any out here, really? Even not many?
No.
That's a void. That's actually a hole through the dust. And you're seeing the stars on the other side.
Gotcha.
So these are stars that are on the other side here, and these are stars that are on the other side, and this is the dust that's way up here in your face.
That's obstruct the stars behind it.
You got it. Isn't that cool?
That is.
Yeah.
Now, is there any filters that can show you that dust? Do you know what I mean? To enhance that it is actually dust in front of those stars, which is blocking the view of them?
Yeah, I mean, first of all, when you take the photos, if I let this stack up for like 50 or so and then process it, you'd clearly see this dust blocking the stars behind. But you could also use the James Webb's infrared systems to easily see what's going on in this dust. It's really cool, yeah.
So they have already done it with the James Webb.
I don't know if they've done. I don't know if they've done this particular nebula.
Okay, but in similar conditions and situations.
Yes, that's right. So now we zoom in here. So here we have a star, and this star is sitting amid a massive amount of dust. All right. So what's happening is the star is made up of red, orange, yellow, green, blue, indigo, and violet light. Okay, so it has red, it has yellow, it has blue. Okay. Well, the blue light is very, very high frequency or short wavelengths. And that short wavelength light is easily absorbed by this dust. All right. And all the rest of the light kind of goes through without being stopped. But the blue light is absorbed and then kicked out in another direction. The overall result is that trillions upon trillions upon trillions of photons of blue light are hitting dust particles and being scattered in all different directions by this process. And so that's why these nebulae look blue. And we have a name for them. They're called reflection nebulae, but they're created by scattering of the blue starlight.
Now, how long in a star in this stage would it take to develop into where it has planets and moons? And is it thousands of years? Like, what's the timing on that, Mark?
Well, let's actually go back here and look at the Iris Nebula.
The reason I ask you that, because if that's far enough, could that actually be already formed? And it obviously would have a different totally look right now, considering that we're looking back in time. Could this already be formed and doesn't have that blue appearance? You know what I mean?
I do. I mean, but the distance of this is actually only 1,300 light years.
Oh, okay.
Right? If it was like 1,000,000 light years away, then you might see something significant. But for 1,300 years, there may not be too much of significance there.
Yeah.
Yeah.
Still, it's beautiful to look at.
It is. It is. Railroad engineer, how you doing? And railroad engineer says, when will we be able to go beyond our solar system? We have already.
I knew you.
Yeah, you knew, yes.
Voyager,
yes. Yeah. But don't worry, Bill won't give it away. Oh, wait. I'm kidding. I did not expect that to be a secret.
Well, you said yes, and I said yes. Actually, we did.
We did. Yeah. So, when you look at what's we've done, we have. But I know what you really mean. You really mean with the eye on being able to explore nearby stars. I get it. And the thing is, the lecture that I've been doing around the country lately is one that borders. Now you can see that brown dust very nicely.
Yeah, and you actually can. Look how
Yeah.
big it is.
Oh, it's massive. It's light years in size. Now let me just kick this up a notch. All right. And now you can see it again. Let me just bring that peak up. Yeah, see, there's the dust. Very clear.
And
There's some out
oh,
here.
See it.
Yeah. So, as far as leaving the solar system, the talk I give around the country now is one called Yes, They Are Here. And it actually talks about the 4 fundamental forces in nature. The strong force, the weak force, the electromagnetic force, and gravity. And no, it's not a lecture on quantum mechanics or even physics. It actually is at a lay level that everybody can understand. And it talks about how using a short little foray into physics at a lay level, you can understand how actually it is possible to travel between the stars. And this process is not with propulsion where you go from point A to point B by traveling through all the intervening points. It's actually a dimensional travel process where you punch out of our 4 dimensions, X, Y, and Z, moving through time. You go into this other dimension, and in that other dimension you go to, the universe is really, really squeezed around you. It's very much smaller and compact and contracted. And that other location has a name. It's called the bulk, B-U-L-K, like bulk produce or whatever. And that's the 5th dimension, it's called. And that 5th dimension is one where if you simply punch out of our 4 dimensions and get into the 5th dimension through a way I'll tell you about in a moment, you could then punch back into the 4 dimensions anywhere you want. Why? Because if you punch into this 5th dimension and you go in far enough, the universe is really, really small around you. So it's easy to go light years from in that perspective, because you can then punch back in light years away from where you were. All right? So you don't even have propulsion on your ship. You just have a way to generate these particular particles that live in this 5th dimension. And if you can do that, as soon as you generate these particles, your ship becomes a 5th dimensional traveler. Okay? This is not Mark D'Antonio's theory. This theory is by the guy by the name of Bob Schroeder, good friend of mine. And there's other physicists in the United States that are on board and say this is the way it works. There's no doubt about it. So, in my lecture, I talk about how this works and the practical applications, what you would see, what it would look like to your eyes, what you'd hear, what would happen. When I was invited to travel on a U.S. submarine several decades ago, not as a sailor, but as a guest. And I still do Navy work today. In fact, I've just been working on some submarine stuff for the Navy today. And during that time that we were at sea, which is a very short time, they saw something rip through the sonar at several hundred miles an hour.
Yep.
Okay? And that was underwater. And nothing goes that fast on planet Earth underwater. Nothing. Not a single thing. So, what does that mean? It means that somehow something can travel that fast underwater and not be affected by the water. The only way that can happen is by this process. And this, we kind of backed into this one because no one knew how they could travel fast underwater like this. But if they use the process I just mentioned with the punching out and punching in, then all they have to do is punch out of the 4 dimensions where they are underwater, go into that 5th dimension, okay, and then punch back in a few feet ahead of where they were. And then keep doing that over and over. Punch out, punch in, punch out, punch in. You say, well, wait a minute, that sounds ridiculous and cumbersome. Not if the computer is running the ship. Because this way you don't even need engines. All you need to do is generate the particles, stop generating the particles, generate the particles, stop generating the particles. And the process can be done fast. So you'll automatically do this bouncing. So the bottom line is you're not in the water and you're not in the fifth dimension. You're always in between. So you don't feel the water pressure. You don't feel the air. This is why they can move through the air potentially and be silent. This is why they don't leave trails in the sky, because they're not actually moving through the air. They're punching into a spot and then punching into the next spot, and the next spot, and the next spot. Little dots that are connected. They don't go the distance between the dots. They go... What?
Question. I got a
Yes?
question. I don't mean to, you know how I am with... Rabbit brings up a good point, and I'm going to add to it. He says, but what about the energy required to punch the dimension? So how would... what would it be to activate those particles?
I was going to get to that next. I really was, because my next thing I was going to say was, okay, so how can you do that? How would you generate the energy to create the particles to go into that fifth dimension? Now, we've heard of the warp drive, and you got to use like the energy of converting Jupiter's mass to energy. Stupendously impossible for probably even an advanced civilization to do. This is looking really nice now, by the way. And we're going to let that build up. And the reason that it will work, and the reason that it can work, is because of the following thing. If you look at the fact that there's no propulsion, then what is it on this UFO, this spaceship, that's actually able to make it leave the four dimensions? Well, the answer can be found both at CERN overseas and Lawrence Livermore here in San Francisco. And what is that answer? Lawrence Livermore has just created, for the first time, well, not just, it was last year or two, they were able to sustain a nuclear fusion reaction. They couldn't get more energy out than they put in, no. But they could make a sustained reaction, something that was very, very difficult to do because the temperatures required in fusion are so high. Okay, so they did that. Meanwhile, what's CERN doing? CERN is building a bunch of new accelerators, and one in particular is going to be used in part to study the effects of a very interesting set of particles. And those particles are the same particles we're talking about to get into the fifth dimension. They're called Kaluza Klein particles, KK gravitons.
So these are scientifically proven to exist.
They're theoretically shown to exist, and Kaluza and Klein came up with this hypothesis, and CERN is going to test it. That's CERN, C-E-R-N. They're the particle accelerator people, the Large Hadron Collider folks. And they're going to test to see whether these particles do exist. And if they do, then the next step is to consider the theory required to make them work. How do you make those particles? Well, Lawrence Livermore, see, back over there. Okay, there's CERN over here. Here's Lawrence Livermore over there. Lawrence Livermore making that fusion reactor leap in capability showed us something very important. It showed us that fusion is really on our horizon. We might eventually be able to have a fusion reactor. Now, what do you need to create the particles that CERN is investigating? A fusion reactor. A fusion accelerator. A particle accelerator to generate the particles that CERN is investigating. And all you need to create them is a fusion reactor. So, that brings up yet another point of obvious connection between a UFO and these objects. And that is, why are UFOs mostly round or triangular? Because they're particle accelerators, circular rings inside the ship, generating KK gravitons to surround the ship, to pull it into the fifth dimension so that it can travel unimpeded by bouncing back and forth. Not in the water, not in the fifth dimension, not really here or there. Always in the in-between. Now, if you think about it, that is truly the only way that they can actually get here from far away. See, you just got my lecture, and it's leaving out lots of detail, but you got the lecture in just a few seconds.
That's fascinating.
Yeah.
Actually.
So here you can see here now you got this beautiful image. You can now we can now zoom in on this. Let's see where it wants to be process wise. So it's gonna do that. Okay, cool. Watch this. We zoom in now. Check out the core of this nebula. Look how detailed that is. Look at this little swirl of dark dust in here. Here is the void. This is the area where there's no dust. You can see through to the stars beyond. Isn't that cool?
That's awesome.
Yeah, and then you got a very, very bright, hot star in there. And actually, if we can drag that down, because we have so many f-stops on this camera that we can do. We got 40 levels. We can actually go in and see what's going on inside this nebula really closely. Look at that. Really complicated stuff in there. All right. And of course, we can then bring it back to where it wants to be, and then boom. Okay. Very nice.
Wow.
Yeah. And we will actually, when we process this, you'll be able to see the separation very, very easily. You see the stuff over here, even on the right side. Let me bring it back so we can grab it. So you got stuff right here.
The blue it looks like almost like a blue cloud. Is that the dust as well?
Actually, the blue is the result of the dust itself scattering the star's blue light and letting the rest go through.
Gotcha.
Rascally Rabbit says KK drive. Yeah, the Kaluza Klein KK drive. And it's the Kaluza Space Klein. Kaluza was a scientist. Klein, nuclear scientist. Kaluza and Klein. Actually, if you want to know more about it, if you look up Kaluza Klein and then CERN, C-E-R-N, you'll actually find a white paper on the CERN website that's talking about the Kaluza Klein particle directly. So now you see it. Right? Now Izabela is saying,
yes.
How such KK drive can be detected on Earth with our current technology? Okay, very good question. Because the answer is that with our current technology, it would be extremely hard to tell what's going on. And the reason is because the object, for instance, that they saw in the sonar in the sub was very, very faint. It was a very faint trace. It wasn't bold and beautiful line because it was little discrete spots. Ping, 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 ping. Okay? Because it's punching out and punching in and doing that over and over and over to go from one point to the next. So in other words, when it goes into the fifth dimension, to just travel like a few, like say you want to go 150 feet, 200 meters or whatever, say, it would actually go and into the fifth dimension just a tiny bit, just enough to punch back in a few feet from where it was, or a few inches even from where it was. But if you're the pilot of the ship, you're just going to say, okay, I want to go from this spot here to that spot over here. And I don't care how you do it. Just make it happen. And so the computer would be smart enough to know how far into the fifth dimension to go before
the punching in and out. Yeah.
Yes, so exactly. See, and you understand this, Bill. And you're not a physicist, but you understand where I'm going. So the thing is...
But here's the thing, though. On the sub, you said that there was this ding, 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 ding going on. Is that what sonar detected? Because
No. I'm saying the ding, 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 ding. That was the discrete... I was trying to say that's the discrete spots. It was almost a silent line. Now, the sonar sees an object at a certain point. Then it sees an object at a certain point. It sees an object at a certain point, a little bit further along. So it builds a line because that's how sonar works.
Right.
But we're used to going from point A to point B by traveling all the intervening points between. That's not how this works. That's not how they work, I'm certain. They pop out and punch in. So they only see discrete points where they pop in, and then they go back to the fifth on land, well, then they're here, and subject to all the things that can happen here, accidents, crashes, whatever, you know. But keep this in mind. These Kaluza Klein Gravitons that surround the ship, when you develop these and from your particle accelerator inside your ship, okay, the Kaluza Klein Gravitons do a lot of things. They will do the following. They will make your ship look almost like it's shimmering, moving in and out of visibility, just like has been reported. They'll make your ship look like it's changing color, just like has been reported. And they'll also absorb the gravitons that the Earth generates. And they will not allow Earth gravity to get to the ship because they are 10 to the 17th times stronger, these little tiny gravitons, than the Earth gravitons. Now, how is that working? It works that way because these 10 to the 17th times powerful gravitons also make micro black holes. And those micro black holes only last a couple of nanoseconds, if that. And that will then create a small, short-lived point
Wormhole?
that pulls in light, the Earth gravitons, and will make the ship look weird to your eyes if it's coating a ship with all these gravitons. So that way, the UFO, the object, is not subject to Earth gravity, and that's why they've been described as looking like falling leaves, because they're not subject to Earth gravity, you know? So that is the weird thing about how these operate. Every observation can be explained prosaically by saying, oh, well, the shimmering and changing color, we'll call it atmospheric scintillation, something lower to the horizon. Yeah, right, I get it. We could talk about an object appearing here in the sky and then boom, it's over there. Well, that could be the autokinetic effect. Your eye is always dancing around when it tries to identify a spot in the sky. It can be described as that too, right?
It cannot be seen by the naked eye. It's just our eyes cannot detect that movement.
Right. So what I'm getting at is it's possible, okay, we can't discount, I should say, that we're looking at Kaluza Klein gravitons in play. You know, and so we can't discount that possibility, is all I'm saying. I'm not saying that's how it's happening. I'm saying we can't discount the possibility that we're looking at a highly advanced technology that uses extremely high gravitational fields and micro black holes in order to create a dimensional travel mechanism. Pretty cool.
Yeah, that is.
And that'll be the lecture at that I'm doing. I'm actually going to do that lecture at Contact in the Desert as well.
What about Roswell?
In Roswell, with additions. Okay? Because I have 16 talks. And this is like just the 9th out of 16. But I do this, I'm going to add to it and it's not going to be old and stale. If you've seen it before, you see it again, you're going to see different stuff making the same points. Because you got to keep it interesting to people. Education is about interest, you know.
By the way, Roswell will be June 28th, 29th, and 30th.
That's right. Yes, I should have no problem going to that now. All right. Okay, we've got the Iris Nebula here. We've got 41 exposures. This will be a amazing nebula. This will come out beautiful. So we'll save it exactly as seen. One last zoom. Look at that. That's going to be beautiful. It's beautiful now. And we zoom out. Now, because we did this before like this, look at now, you can clearly see the color here. Okay, you can clearly see the color of this dust. All right, it's going to be a silicon and carbon-based dust.
I can't imagine if there was an exoplanet in that neighborhood, what that would look like in their night sky.
Actually, there may very well be exoplanets here in this region, because this is a region where the hot stars, okay, where the hot stars actually if they were here, they're now gone. They've gone supernova. Maybe this dust is from them. Maybe it's from somewhere else. And we're billions of years past that. So now, this might be a prime time. But, okay, there's undoubtedly hydrogen here, too, in here. But we're not seeing any ionization, which means that the star is probably not one of those super hot stars. And even if it's there, you can still have something down here, over here, or out there in this cloud, elsewhere. And it doesn't even have to be in the cloud. It could be somewhere out in the intervening space where this dust has been used up to make planets and the gas available used up to make a star somewhere. So there's a lot potentially going on here. All right, so I'm going to save it one more time. And then we're going to save exactly as seen.
That's great images already tonight.
Is that?
Mm-hmm.
All right, and now we'll come out of here. Go back to our night vision view. And go to another object. Here we go. Again, SkyTourLive.org. Scroll down to the dark gray panel and it'll tell you how to access all of the files we're taking pictures of tonight. Alright, you're all free to go in and do that. Izabela says the iris is difficult to process, though. It can be, but what I did tonight, Izabela, was to go longer on it in order to help differentiate that dark nebula from the background, and it was very successful. You can clearly see the brown against the black of space. All right, so let's come back here. All right, and we'll back out. All right, and now unfortunately, we have the winter sky coming up already, which is, okay, I guess. But I would like to take us to, I don't want to do that yet. So what I'll do is, well, we have the Heart and Soul Nebula. If you haven't seen the Heart Nebula in this, you owe it to yourself, okay? Because the Heart Nebula is really just astonishing. All right, and let's go here. All right. So watch the telescope. It's going to start leaning that way, going out the back. And it's more than high enough to see. After all, we can see Polaris with the scope, and Polaris is down here.
So cool to see it moving.
I know. All right.
It looks like it's kind of low in the sky.
Well, there's Polaris, and we can see Polaris unimpeded with this telescope. So it's well above Polaris. See? There's Polaris. And we can see that. This is where we're looking. So we're going to see it right here. Oh, yeah. The Heart Nebula is just stunner. It's a stunner. And we want that. So I'm going to bring us up here. Like this. I believe we're going to do this. This is what we want. I might be wrong. Maybe I'm not wrong. Go west a little bit. That's a hot cluster in there. And we want what's here just to show you the incredible, amazing stuff in there. So we're just going to go check it out and see what it looks like. It'll do a quick shot. And I won't even use the live stack right now. I just want to grab a quick shot of it. The Heart Nebula, so named because it looks like a heart.
Makes sense.
Yeah.
Yeah, nice on something for Valentine's Day. A nice card with that on it, huh?
Mm-hmm. Yeah, that's what we want right there. This is what we want right here. Actually, this is a pretty good view. So we're gonna just we'll live stack this and get rid of this guy and minimize our other histogram view, our adjustments. So here it comes. Check this out. Look at that. This is a beautiful region in the Heart Nebula. It's a beautiful song for digging through the Heart Nebula. Now we have one exposure here. If we zoom in, okay, watch how it clears up in just a second. Now it's going to get a little clearer. Look at that. After the second one gets stacked, things become much more clearer, and it just gets clearer and clearer and clearer from here on out. This is a region in the sky that's actually a stellar nursery, a nebula right here. This is a young cluster that formed in here. It's ionizing the hydrogen gas throughout here, causing it to glow beautifully like this.
That is awesome.
Oh, it gets better. Let's color correct this. Yeah, color correction starts to show a little better. And then let's see where it wants to process out as. Yeah, that's what I thought. It's gonna... I tend to run it like this. I contrast it just a little bit more. There we go.
Wow.
Yeah. Okay. Okay, RGPX says, Mark, where you are, Polaris is easily, 45 degrees in elevation? Because I used to live in the Chicago Metro, and that was, we're at 31 degrees latitude down in that area. Okay. So we are at 31. So if you come back here, all right, if we come back here and just come out of here, let's go to Polaris for a minute and select Polaris. Okay, there's Polaris. Okay. Right. The altitude of Polaris is 33. Actually, we're at 33, sorry. 33 degrees. All right. And we're at 33 degrees in latitude there. So now we're going to focus ourselves on this. There we go. This red box is our view. Okay. Look at that. Look how much it's gotten better since we... This is just 7. What do you think, Bill? Isn't this something, huh?
I'm telling you, I'm already thinking of some slogans and lines and even the insert of for Valentine's Day with this one.
Oh, yeah.
This is amazing.
And this, if you'll notice, you see a bright line, then it gets a little dim, and a bright line, a little dim, bright line.
What is that?
That's a tumbler. It's a tumbling rocket body.
Really?
Yeah.
Wow.
We caught a little space junk. But that'll go away because that's a dim line, and as it's only on like a few frames and not in the same place. So this line will disappear with the addition of new color data from behind it in this nebula. It will overwhelm it. Look at this. Isn't that incredible?
Mm-hmm.
That is just beautiful.
Another beautiful thing that would look awesome on a wall, framed.
Oh, yeah. Yeah. You can get the Heart Nebula in full wide-angle view at SkyTourLive.com. And you can go to our darkroom photos and get them on canvas, metal, under glass. It's just beautiful. You know?
Mm-hmm. Yeah, that's stunning.
We got a lot of really good conversation going on in chat over there, Bill.
What's going on in there? I see Lubo in China.
Yeah, Lubo's here from China. Yep. Yeah, Lubo says, yeah,
Old schools that hit the hay.
it does look like a bonsai. Okay, Leon, thank you for coming, man. It was good to have you here with us. Old schoolie is Leon.
Good night, Leon.
Yeah, pleasure having you, Leon. Thank you. Okay, well, since we're at 12, I'm gonna knock that down, and I am going to get rid of this right here for now.
It's amazing, like you said earlier, how much hydrogen is out there.
Oh yeah, most plentiful element in the whole universe.
Unbelievable. And the green is oxygen, I think you mentioned?
Correct.
Okay.
Yep. Yeah, it's all hydrogen here. There's no real green in here. But look what this camera's showing us. Okay? These beautiful tendrils, this stuff here. Very, very complicated region. Little weird things like this. This is just incredible. I'm going to look at this detail here. That's just incredible. Let me try to pull a little more detail out of this.
So, if this is, obviously it's light years away, but
Yes.
if this expands light years, would that mean if you were somewhere in there, you would still see it around you, maybe because it's light years apart, the reddish in the sky if you were there, because it expands light years? Is that something that's possible, Mark?
Oh, well, okay. I'm not sure I follow the question, but let's just, the second part I do. First of all, this hydrogen glow is something that would have to be really, really strong,
Right.
for you to see with your eye. And with your eye, it would look white to you because it's dim. When you look at the Orion Nebula through a telescope, you don't see the red streamers from the Orion Nebula. You see a white set of streamers. And your eyes are actually tuned to see green more than any other color. So they would actually see the oxygen in the Orion Nebula as a slight touch of green. And but it needs a lot of data going into those eyes, because the cones, which are the color receptors, are focused in the center of the eye, need a lot of light hitting them in order for the color to be seeable or discernible. But the rods, which are black and white receptors around the outside of the eye, those can pick up light very easily from the edges and put it through to the retina, to the optical center, the visual cortex. And so that kind of light will come in looking black and white because the rods see in black and white. The cones are the only color receptors, and they're not as sensitive. It would have to be very dense and very bright for you to see any color in a nebula. And in a telescope, a big enough telescope, the Orion Nebula could appear to you in some version of color. But it would take some time for that to be noticeable by you.
It's still, I mean, from our perspective, through this, it's just stunning.
Yeah. Rascally Rabbit, just to let you know, there are people with very bright skies. He's talking about not having a bright enough sky. And what they do is they use what are called narrowband filters. Okay? You look for the hydrogen alpha, which is this red stuff. That's a filter specifically for hydrogen alpha. You look for the oxygen 3, specifically for the blue stuff, like in the Dumbbell Nebula we saw earlier. And you look for the sulfur 2, which is the other component in nebulae that you see a lot. And you use those 3 filters, and you take a black and white image of each, and then you can combine them together into a color image in Photoshop. And then you can actually make what we call the Hubble palette, so you have things in the Hubble colors. We don't use the Hubble palette. But I think that is I think that's something that you would actually end up doing, just to be able to see a nebula like that from a brightly lit sky, because those narrowband filters won't let any of this other light in. That's stray light that's poisoning your view.
Hmm.
You know.
Have you ever tried to zoom in into Europa or something within our solar system? I mean, obviously people look at the moon and Saturn or with the rings or whatever. But have you ever, because I find Europa so fascinating, Mark.
Yeah, Europa is only a tiny dot to us, and
Is it?
even to the Hubble Space Telescope, you know, the Hubble shows Europa as a small disk and not with lots and lots of detail. JWST can see it with better resolution, but it's still just a disk, a small disk. It's not a detailed surface that you can really tell.
Yeah.
It's just too far away. Europa's only 1,900 miles across, and it's literally 5.2 astronomical units away. That's 5 times 93 million miles. Okay, so you're looking at something that's actually, almost 100,000 miles away per astronomical unit. It's almost 500,000, 500,000 miles away, right? 93 million, I should say. 500 million miles away. So we're talking a great distance away. Yeah.
I think they've got stuff getting there. I think I read it that by 2030, that's when they're going to be sending some stuff over there. Satellites, some kind of scientific data. Mom, what the heck is going on here? You see all the commotion. Mom's in the background. But I read that the ESA, us, the United States, we're sending a bunch of there by 2030.
Nice. So look at how this is developed. You can see all the little strands in here of dark nebula. This is beautiful. This is beautiful. You notice that it seems to be sticking out toward the right. See that? Sticking out toward the right. This little thing is sticking out toward the right. Why is that? Well, it's possible that this cluster of stars has a combined set of stellar winds that are blowing the dust back and clearing this whole region around it. Now, we don't know three-dimensionally what this looks like. Okay, so it's possible that there's more going on here than meets the eye. But boy, oh boy, look at this. This is such a beautiful central region of the Heart Nebula. Isn't that something?
It is.
Wow. Yeah, there's another part of this that we aren't able to image yet because it's actually out to the upper right here. It's called the Fishhead Nebula. It's the brightest part of this nebula. This is dimmer than the Fishhead, which is up here somewhere.
Look at that. When you zoom out like that, you see the size, and it's incredible.
I know. It's just really something. You know? Unbelievable.
Wow. It really is. It
Yeah.
really does look like a heart, too.
Yeah. And we're going to change our name up here to Heart Nebula. Okay. That name is what appears in the directory up on our database. So when you go to look at that, that's what you'll see. Okay. Let's bring the telescope back here. All right. Okay. Let's just zoom into it. I gotta just check that out.
It really is, Renee.
Now let's zoom in here and very, very detailed. Now let's see if we can tease some more detail out here.
So is that more dense of dust in these darker spots? Or
Yes. It's denser. Yeah, that's correct. Wow, look at that. Yeah, this dust is more dense. That's why you see it. There's dust all throughout here.
Yeah, yeah.
But this is a particularly dense little region here. Obviously very dense over here. And what's very dense? Well, very dense means maybe 30,000 atoms per cubic centimeter. All right? Now that sounds like a lot. But in air, there's 10 to the 19th atoms per cubic centimeter. Okay? 10 to the 19th versus 30,000. Vastly different amounts. In fact, there's so little dust here, all right, that if you went through it with your spaceship, you probably wouldn't even notice you were going through dust. Because it would take lots and lots of, like, maybe millions of miles to actually notice that there's any kind of dust around you. So it's pretty cool.
It is.
Yeah. So I think that's something. So let me see if I can pull down the noise a little. Yeah, look at that. So gorgeous, gorgeous, gorgeous. Yeah. So let's zoom back out again. Let's go where it wants to go.
Oh my gosh, even like that zoomed out, it's amazing.
Yeah. I mean, this is several light years across. Maybe this could be maybe 20 light years across, 25 light years across.
Oh, that's unbelievable. Just think about it that way.
I know. And we can't even go a 500th of a light year. You know? Not yet. All right, let's see what happens here. Oh, yeah, look at that.
Wow.
Color correction makes it all worth it. Let's pull this over. Look at that. This is live. This is
wow.
This is all live.
That is a keeper there.
Oh yeah. So I'm gonna save it.
Heck yeah.
Okay, so it's saved. And I'll save this exactly as seen, but I'm gonna also go back to where it wants to be, and then
I need screensavers, Mark. This would be like
I know, right?
Oh my gosh, imagine having that on your screens as a screensaver.
Yeah, and they're huge files too.
Yeah.
Yeah. The size, okay, the capture area, the size of our sensor is 5,500 by 3,600 pixels across.
Wow.
So that's a pretty good size.
Mm-hmm.
All right. So I'm going to save this again like this. This will save the image just exactly as we saw it. All right. So now, if we actually go look at the image, this is what's actually saved on the server.
Wow,
This
that
one
is
right
awesome.
here. Yeah, and you could do things like this. Zoom right in. Okay. Oh, look, looks like a chicken with an eyeball and a beak. It's one of those rubber chickens. Okay. There you go. Look at that. So that's basically what's there. That was the exact file that's going to be up online in just a few seconds. So it takes about maybe 30 seconds. So from the time I say save to the time it actually shows up. Okay, I hit save again there. From the time I hit save to the time it shows up is about 30 seconds, maybe 35 seconds. So that's something else. Wow. All right. So now we have one more object to look at tonight.
Good.
And-
We got a meeting early in the morning.
Oh, okay.
Oh my God. Of course we're learning. I that's the one thing. Every time you go to Mark's presentations, you're going to definitely have it's great. I'm going to tell you, if you can go to Roswell or Contact in the Desert or any of the events that Mark's part of, it's one thing when you see him doing this here, it's amazing. I can't emphasize it enough how awesome it is when you go to see him in person and see his presentations.
Oh, we had a good time at Roswell, without a doubt.
Yeah, once we got everything to work.
Yeah, but keep in mind that was only the second time we've ever done a live studio audience SkyTour.
No, but it wasn't necessarily your fault. There was things going on in Roswell too.
I understand.
Because we all tried to help earlier in the day with others. It was a little challenging with the way everything was set up, but I'm sure that'll
without a doubt. Okay, let's see here. All right, those look like, okay, that's that.
Yes, Lee. Rest in peace, Lee Spiegel, for sure.
Yes.
Man was a legend, pioneer in the field.
Yeah, Lee and I were very, very good friends.
Yeah.
And it was very sad.
Very.
Yeah, to be without him after all these years was just awful. But okay, let's see here. Well, I think I have to.
I will say this though. Can I do a selfish little teaser plug for KGRA?
Of course.
Coming up, probably. I think it's going to. I don't know the date. I think it's Thursday, November 2nd.
Okay.
The premiere from 8 to 10 Eastern. The premiere of UAP Crossfire. It's a panel show. I don't think they're going to have much guests on the show at all. It's Martin Willis, Don Ecker, the return of Commander Cobra, and Chris DiPerno. And they're just going to talk about the latest going on in the field of the UAP and all the stuff that's surrounding the news. And this, I've already recorded 2 episodes. We pre-recorded 2.
Excellent.
Because Commander's schedule. And I'm telling you, this is going to be one heck of a show.
Excellent.
So stand for that. And also, as Mark knows already, the Roswell Daily Record live is coming to KGRA. So the Roswell Daily Record show.
That'll be a good show.
Yeah, with Toby and Maximo. You met Maximo, right?
Yeah.
Yeah, Maximo's his co-host. So be prepared for that. That's just a couple of teasers. There's a lot more that I'm working on. But anyway, getting back to that. That line, what is that line now?
That's a satellite.
Is it?
Slow mover, actually. I took a 25-second exposure, and it took 25 seconds to go that far. So that's a satellite that's further out. I'm going to do one more thing here. Let me grab this here. I'm waiting for my Starlink to come back.
How has that been, Mark, for you over there at the Starlink? Has it been pretty much reliable?
Yeah, actually, it has been. It hasn't been bad at all. Hang on, I'll be right back to you. Okay, there we go. And let's go back to this. 1 second here. I'm going to bring this up and drag this back over where it belongs. Okay, here we go. Okay, so now I'm going to move us down here. I believe this is the right location. And then we're going to move a little bit west, center up that cluster that's to the right edge of the screen right now.
Thank you, James, for doing that.
Thank you, James. Yeah, we're on Rumble as well. Okay. Now we're going to try this. We just looked at the Heart Nebula, and this is the Soul Nebula. So we have Heart and Soul. So hopefully, this should be a really pretty location. So you have a meeting tomorrow, you said, Bill?
Yeah. It's actually a very important one.
Well, tell us all about it.
No, I can't. I can't.
Oh, no, you can tell us everything.
You know me. When I have a big mouth, but when I gotta shut up, I shut up.
It's true. Ah, there we go. Nicely centered. This is the Soul Nebula. This is a hot young cluster. It's, of course, forming this cavity here. But the Soul has this beautiful region over here, which is going to develop in this gorgeous pillar here, probably from young hot stars over here that are forcing this gas back potentially and causing a lot of turbulent eddies. You'll notice this satellite is still going through. It's taking a while. Yeah, Rascally says, just tell me and James and Mark. Yeah, come on, Bill. Pretend no one's listening.
Let's just say the tease is...
Here it comes, folks. He's going to give it away now. But go ahead, Bill. Tell us again.
No. It's being able to stream audio-wise on many more platforms. Every possible platform you could think of. With the help of someone in this company. And, yeah, we're expanding big time audio-wise.
All right. That's fair enough.
That's as best as you're going to get. That's all I can talk about.
So what is Jimmy doing for you?
No. Her name is actually Amy.
Oh, okay. Now we got her name, guys. See, just
good luck trying to find out the rest, but...
Well, we got part of this already. Don't worry. We'll have it all figured out by the time we're done.
So SkyTour, the show, when he does it on Sundays, is going to be heard on, like, my God, 40, 50 different audio platforms. Believe me, they do exist. It's not just the usual Spotify, iHeart, Apple, all the ones that people know. There's a lot. There's a lot of other ones, too, that reach has a global reach in certain countries. So we're trying to get more international reaching.
All right.
You know what I mean?
I do. Now, the question I'm going to ask you is, are we still going to get iHeart, Spotify?
Oh, yeah. That's already happening.
Okay. But after all this, I'd love to know who's actually listening to the show. Are we going to be able to get that yet? That's the killer right there, folks.
That's the killer because it's. I don't want to get too much into the technical aspect, but Spreaker is not an easy place to get numbers for a network. It could be a separate podcast. If you're a podcaster and you're on Spreaker, you can get your numbers. But when you're a network with so many shows, they don't do it that way, Mark. We've been working with them very closely, and they're tough. They're tough to get the numbers.
Gladys is funny. She says you're going to build a giant satellite.
And radio it to the aliens.
Yeah.
But yeah, we're working on some really interesting areas.
Awesome.
Actually, we're doing the first thing, Mark. We're dual streaming now. We're running 2 shows live at the same time on video.
Oh yeah, I knew you were doing that, and I guess that you've become your own competition because if someone is going from 6 to 8 on a Sunday night, you can have someone else going 6 to 8 on Sunday night as well.
Not on the weekends. Not right now, no.
Okay.
And it's two different types of shows. Like, for example, you have Kriston's show, The Rundown Live,
Yes.
running at the same time MUFON What's Up is on. So they're two different types of shows.
Okay.
It's not going to take away from the other. It's totally different.
That's good to know.
Because there's an audience for everything. And
There
not,
is.
some don't want to hear certain things, and the other they tune in and out. It depends on the programming.
Yeah, you
So-
know.
Don't worry, SkyTour is definitely a standalone one and always will be as long as I'm in charge.
Well, that's nice to hear you say that. I'm not worried about it.
No, that's a standalone show.
And he's talking about SkyTour Radio, guys. The Sunday.
Yeah. He calls it SkyTour Radio. I took the radio out because it's videos. I just call it SkyTour now.
Oh, okay. That's good to know as well.
Who I may be going, if he does a show Sunday, I may be just about maybe going on with him live.
Yeah, actually, he talked about that today, and that would be great.
Yeah.
Okay, so
So
there's the Soul Nebula right there. And the Heart Nebula is just above it. I don't think we did this close enough to be able to show Heart and Soul together. I think we'd have to do one more intermediate frame, but we'll wait on that. We'll wait on that. Actually, Ronald, it was SkyTour Radio. It was never a SkyTour Live Radio.
Yeah, it was SkyTour Radio.
Yeah. So we used to abbreviate it STR, and then this is STLS.
Tracy is coming back in January.
Yes, Tracy Austin. Rascal the Rabbit says, Filet of Soul. Heck yeah.
That is another stunning image.
This is going to get more and more beautiful. It's only 14. But this has all these beautiful convolutions over here. This is really stunning up there. Just gorgeous. Oh, yeah. So 15 images. So the Soul Nebula and the Heart Nebula are near each other in the sky, as I mentioned. So there is the Soul Nebula, and here is the Heart. Now we were in the middle of the Heart here, and then I'd have to take an intermediate shot to kind of overlaps the two of them, and then take one that goes in here for them to be, ability to be mosaic. But don't need to do that.
Yeah. But you can see the proximity.
Oh yeah, I mean, I did the North American Nebula yesterday on my own. I just did a nighttime. I wanted to just do something, so I actually built a mosaic of the entire North American Nebula. I showed everybody earlier. I think you missed it.
Yeah.
But it was really, really cool. It was very cool. Yep. So let's look back here now. Look at that, guys. This is really looking pretty now. And this is, the guiding is, really well done.
The upgrade to your cameras is really night and day.
It is night and day. We've gotten a lot more detail in this particular camera. Look at this little region over here. I mean, this is a beautiful dark nebula coursing through this whole region. We see tendrils. Stuff like this was not very detailed for us last time, the other camera, but now it's quite detailed.
Oh.
The other thing too, the other thing too about this is if you look, let me actually bring this down where it belongs here in just a sec. There we go, right there. Okay. The other thing too about this to notice is that this guy right here, all right, that black dark cloud right there, all right, is an area that's really dense and relatively so, whereas this out here might have, say, 4,000 atoms per cubic centimeter. This might have 15,000 atoms per cubic centimeter. So it's actually getting densified, getting more density. And so this could actually be an area that's gravitationally contracting to form potentially a star or potentially a stellar system of planets, potentially, at some point. So there's a lot going on in that little tiny object right there. Let me just put myself back in the corner over here. I belong in the corner. Hey, don't be laughing at me, or I'll tell people how you dropped 1 billion years on me.
No, that's so cool. The floating mark. Oh.
Well, I mean, it's a way to point things out. It's just a.
It is. It's great. It's great.
It's helpful. Yep. And like this cluster is actually a cluster that's probably powering a lot of what you're seeing here. A lot of this nebula up here. This is all powered by that cluster. So there's a lot of responsibility for this star cluster in this nebula.
Oh.
And that's pretty. So let's see if we can zoom in on that now. Oh, look at that. Now we're seeing other detail in there that we didn't see before. This was all invisible to us with the other camera. It was just invisible. Not visible at all. Let me see if I can get some more detail out of it. There we are. And you look at our stars, and now we are zoomed into 70%. We're not at 100% of our sensor, okay? But if we just go to 100%, you can see the native resolution. This here is the native resolution of this camera, okay? So it goes all the way across the screen. You can see how much of this goes outside the boundary of the screen here. It's just a massive amount. Wow. And here comes that beautiful little tendril, actually cone of hydrogen gas. Yeah, that's something. So I'll zoom out all the way.
Wow, that is cool.
And you zoom out all the way. Now you can actually see it in all its glory. And let's make it even better. Move that out of the way. And let's move our telescope out of the way and zoom in to the beautiful meatball that is the Soul Nebula. Look at that. And let's actually darken up our star background. This is the black background. Let's actually darken it up a little more.
Did something happen in the middle of that? Because it seems like everything's going outward from the center point.
Yes, something did happen. This star cluster was born. Okay, and like with the rosette, you notice it's curved here.
Mm-hmm.
Okay, also notice down here, now that we're getting more resolution, and let me zoom in. Okay, what do you see? You see these pillars here?
Mm-hmm.
Yeah, so the pillars of creation that Hubble photographed. Well, these are also pillars of creation, effectively, because they're all pointing at something, aren't they? They're pointing at this star cluster. Okay, so what's happening is, most likely, these stars are radiating so much energy that they're pushing gas and dust down away, but only the dense front ends of this, where there's a dense area, is remaining, and so it prevents the stars from evaporating what's behind this. So that's why what's behind it is staying intact, potentially. So we see that a lot in the universe. We see a lot of that where we see these spires, or these columns,
Mm-hmm.
right? These plumes that are just evaporating material. So it happens a lot. We see that in many places, especially in the Eagle Nebula at Measure 16, you know. Very cool. This is a beautiful location, and just got a tremendously beautiful, very beautiful outcome here. Look at that. That's there's your universe, folks. Welcome to the universe, live in real time.
And we're just such a very, 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 very small part of it.
Well, yeah.
I mean, it's literally, I wouldn't even say needle in a haystack because it's much bigger than that.
It's true. It's true. Yeah, you're right. So let's see where it wants to be for processing. Okay, not too far away. But you see these are the spires. And when we process these, we do our professional processing, what we do is we literally put all the stars on a separate layer. And we just look at the nebula alone without any stars in the field of view. And there's an AI process that we use to remove the stars. And it's beautiful. It works great. And the process allows us to process and bring out details in just the nebula without affecting the stars around it. That's really important.
Mm-hmm.
Yep, very important.
It's so clear. I mean,
yeah. And it would even be clearer on a big screen 80-inch television, high def.
No doubt. No doubt.
Here, let's bring our telescope back. Move over. Yeah. It's weird. I just can't get over the fact that I'm looking at our telescope 2,500 miles away and getting an image from 2,500 miles away and sending it all over the world. My mind has trouble grasping that. Yet it's exactly the kind of thing that I was cut out to do.
I remember the beginning.
You do, actually. You were part of it. You guys encouraged me to stream. You and Keith, P&K Space Imaging. You know?
Look how far it's come, Mark.
I know. This is crazy. Don't you think I should just stop and go away?
SkyTour East.
It started with SkyTour East, that's right. And then I love my sky, but the western sky was so much better in terms of clarity of the sky, beautiful night sky. So
it still was cool to have a dome in front of your house, because I remember when you installed it and
you came to see it.
Yeah, I remember that. That was so cool.
We're gonna be putting the other one out there, and it won't be a dome, but it's gonna be much cooler. And the reason is because we have these linear actuators, which are long. Like the door closers on your door, and it closes, doesn't let it slam. It's like those little hydraulic pistons, which just close the door gently.
Yep.
Well, imagine if you had a motor at the other end, pushing that piston out and pulling that piston in. That's a linear actuator. They make them in all sizes and all strengths. I bought 2 of them that can push 600 pounds a piece. So I can have a snow-covered roof with 3 feet of snow on it, and I could lift that roof right off the building, dump the snow, and put it back on. All right. So this is going to be a linear actuated roof removal for us. And it's going to pull part of the sides with it so that the telescope will be more exposed and have a much better field of view than this telescope does. This is a roll-off roof. And this telescope I could convert, actually, to make this telescope, put it on what's called a lifting column. You know, there's sit-stand desk. You push a button and the whole desk goes zzz, raises up or lowers. Those are on pistons that are like linear actuators. In fact, there are linear actuators in these rectangular tubes. Well, because I can tell where the telescope is at any time, I would be able to easily align the telescope and have many times, and then actually raise the telescope up like 17 inches higher than where it is. And that would give us access to seeing stuff on the horizon that we can't see.
No obstruction.
Yeah, no obstruction. Anyway, well, there we go. This is the Soul Nebula. And we're going to save it right here. And save
Mark,
it exactly as seen.
Thank you for having me on for a bit here tonight.
Of course. And this is the last object, folks. So hopefully you guys had a really good time, as I did. I look forward to hanging with you again. And Bill, you know, I'll deal with you.
Necessarily a threat, but I'll be back.
You will. Everything will be fine, actually, and we're gonna have a good time. So, I will. I'll check in with all of you on the next clear night that we stream. Okay. So, have a good night. And
Good night, everybody.
there you go. All right. And Bill, I'll be right back to you right after we hang up here. Okay. Good night, everybody. Have a good evening. And thanks for coming.